Good evening friends. So happy to see you once again. So I will give the solutions for the power system subject. So along with me Bhupender sir is also there. He will also give the topics related to his concepts. So related to the question numbers one by one we will discuss related to the power system subject. So this is actually question given for the reactive power calculation. So what is asking in the question is how much is the generator of Y connected generator is supplying power to the load. For that simple one you can take the total 3-phase power total 3-phase power. This will give 3 times of per phase power you can take, that will give 3. So per phase power you can calculate because he has given the line voltage of the generator, that will give convert into phase voltage, or Y connected means line and phase both are same and E the power factor of sin phi. So in this the line voltage is given of 20 kV, so that you can substitute 3 into 20 by root 3, and the current of IL is given of 10 amps. You can take 10 cube, actually you can take this value is 10 amps, and power factor is 0.8, lagging is given, power factor is cos phi, sin phi is becoming 0.6. If you calculate all this one, you will get the answer for this one is 207.84 kVAr. So answer for this question is of B. B is the answer you will get for this one. This is question number 8. Okay, right. You will see the next question. This is related to the corona. So related to the corona part. In this corona, what we studied, we have know this concept is what called critical disruptive voltage. So this critical disruptive voltage, if we write down the equation for this equation, so this is the equation for the critical disruptive voltage. So this critical disruptive voltage is proportional to the delta. What is delta is also depending on the factor of B. What is B is given by atmospheric pressure. B is actually given by atmospheric pressure. So if you take an hill areas point of view, this B value is low. Whenever B value is low, then delta will be less, Vc will be less. Whenever Vc is less, because of the delta is less, then this causes more corona. So in case of hill areas, corona will be more compared to the plain areas. What is asking in the question, be careful while answering the question here. In this one, this is actually what is given, this one is not correct. The corona loss is less in hill areas than the plain areas. This one is wrong. Corona is more in hill areas compared to the plain areas. So that answer for this one is B is the answer. Okay. Next, if you see this related to the cables, in case of power cables, we have seen the condition for most economic size of the cable. Most economic size of the cable. For this most economic size, general case, if you take the maximum electrical field, generalized equation you are getting is V by small r by small r ln of capital R by small r. What is small r is actually the inner diameter and capital R is the outer diameter. This is actually small r and this one is actually our capital R. So r is the core diameter or conductor diameter. Capital R is actually taken off at total diameter of this complete cable core diameter is what is asking. In this one, the E max value you can able to reduce at a condition of R by R equal to E, then this value of E is becoming now V by R. From this you can calculate R value, that R value is given by V by E. This is one part. What is asking in the question, just read this one. He is asking about economic overall diameter of the single core cable. For this economic overall diameter, just you can calculate simple one. You take this one is capital R is the diameter radius. What is overall diameter is given by 2R, because this is actually the overall diameter of the cable, that will give the 2R is the overall diameter. I can put capital D. So if you take D, D is given by 2 into capital R, that means 2, what is the condition here? R by R equal to E, that value of small r you can substitute here, that will give 2E into what? V by E. From this substitute the values here, 2 into, the voltage is actually given here of 85 kV is the voltage, and the electrical field is given of how much is 65 kV, that value you can substitute, that will give us 85 by 65 into E. And finally, this is actually given by 2.615 will get 2.615 into E will get the value, approximately this value get is 2.6 times of E. So, the answer for this one we are getting is of B is the answer for this, 2.6 times of E is the value. Okay. So, next one, what is the percentage increase in the bus bar voltage required to compensate? For this part also, just you can think of a transmission line or bus bar, you can take these Vs and these R and XL is their VR, and if you connect a lagging load is connected, assume that lagging load is connected with some power factor of cos phi, and the current is drawing, this is a full load current of taken of I. Then if you take this R and XL both are taken, the voltage drop of Vs minus Vr, this you know this simple equation, I into R cos phi R plus XL into sin phi. This is the voltage drop. But in the given question, he is not given the resistance, he has given only the reactance is actually given, this value is 5% and full load current is power factor is given by 0.8. So, this part is becoming 0 now. So, this value of Vs minus Vr you can take, this will give us I into what? A simple XL into what? Sin phi. So, he is just asking about at full load current what a percentage of increment value. So, for this one power factor is given of 0.8, lagging is given, cos phi is 0.8, then sin phi is becoming now 0.6. So, that XL value is 0.5. So, what is the percentage of increment in the voltage, that you can take this value is 0.5% or this is given by 5%. This value is given by the 5%, 5% of into 0.6, that actually comes is what? 3% is the increment in the, what is the bus bar voltage is required to increase this value. So, that finally answer for this question is, you are getting 3% is the value, answer is A for this one. Okay. So, this is related to the our relays. In case of relays point of view, this is the graph operating time versus the multiplied settings. This D is actually given by extremely inverse, this is for extremely inverse, this is for very inverse, and this is for the inverse, and the last one is IDMT. This is actually given by inverse definite minimum time point of, you can take this characteristic. So, here what is asking in the question is curve B is related to what? The curve B in the characteristic is related to what? Inverse time. So, if you take this one is of inverse time, that inverse time is actually given by B. So, the answer for this one is, sorry, 1 minute, in this one, give this names here. Next one.
I will have to do undo, I think.
Can do undo.
Here we
1 minute. What is about this? Okay. Wait a minute. पूरा स्क्रीन भर गया.
सर इसी को ना बैक वाले
you can write on the.
Yeah, I will write down. Just is actually asking like this. So, this is the current and this is the time. PSM plug setting multiplier point of is asking. So, we have the graphs like this. This is actually given by D and this is given by C and E is of B. and one more is actually given by A. So, if you see this characteristic point of view, all this one, D is, this is actually what you will get extremely inverse. D is very inverse, this one is inverse, this one is actually taken off inverse definite minimum time. This is the characteristic what is asking. Curve B is what is asking curve B. What is the word curve B? This is related to what? Inverse time. So, that answer for this one is of C is the answer for this question. So, question number 101, answer for this one is C is the answer we will get. Okay, right. See the next one, I will increase the size. You can select, yeah.
yes, yes. बस बहुत ज़्यादा
Right. So, he is asking about the question number 102. The arcing time of arc control circuit breaker varies considerably depending upon the breaking current. Except for a certain medium range of voltages, arc current circuit breakers are widely used for the low voltage circuits as well as the highest transmission voltages. So, if we read all these points here one by one, what is asking this in this particular question is which are not true. So, for this particular question, answer for this one is A is the answer for this part. So, this is actually depending on the what is about the arcing time is one part. This is what the statement he has given, this is also one is wrong. Another one is for a certain medium voltages, and where actually you can use when for the high voltages point of view, highest transmission voltage point of view, generally they do not prefer this air brake type of circuit breakers. We can generally prefer of SF6 breakers are used. It is generally preferred for the low voltage control only it can be used. Okay? For that this statement is also wrong, right. Yeah, now Bhupendra will take care of.
So, this question number 103, in this question they have specified the different type of buses and what are the specified quantities and what are the unspecified quantities. They have given this in the form of set A, set B, set C and set D. So, ये आसान क्वेश्चन है, आप आसानी से इसको समझ सकते हैं. जैसे अगर हमने कहा कि लोड बस की बात करें तो लोड बस के लिए सेट ए में इन्होंने लिखा है सेट ऑफ क्वांटिटीज टू बी स्पेसिफाइड ऑन द बस. सो लोड बस पे क्या क्या स्पेसिफाइड होती है. लोड बस इज द पी क्यू बस. तो पी और क्यू स्पेसिफाइड होता है और अननोन क्या होता है, सेट ऑफ क्वांटिटीज टू बी ऑब्टेन्ड मीन्स अननोन क्या होगा. सो मॉड वी और डेल्टा हम लोग यहाँ सॉल्व करते हैं. तो ये पी और क्यू हो गया सेट ए और सेट डी हो गया वी एंड डेल्टा. ऐसे ही स्लैक बस की अगर बात करें तो स्लैक बस पे हमको पता है स्पेसिफाइड मॉड वी डेल्टा होता है, अनस्पेसिफाइड पी और क्यू होता है. तो सेट बी क्या हो गया, इन्होंने कहा कि स्लैक बस पे सेट बी स्पेसिफाइड होता है और हमको पता है स्लैक बस पे मॉड वी डेल्टा स्पेसिफाइड होता है, यानी मॉड वी डेल्टा जो है वो सेट बी है, दिस इज सेट बी. और अनस्पेसिफाइड इन्होंने कहा सेट ए सेट ई है. सो हम देख सकते हैं ये सेट ए और ई सेम है. सो ए एंड ई आर सेम, ए एंड ई आर सेम. साथ में जनरेटर बस की बात करें तो जनरेटर बस पे हमको पता है, माइक तो ठीक है, आवाज आ रहा है, चलो ठीक. जनरेटर बस जो है, जनरेटर बस पे जो है पीवी बस की तरह हम देखेंगे तो पी और मॉड वी नोन है, क्यू और डेल्टा अननोन है, यानी हमारा सेट सी है पी डेल्टा. दिस इज सेट सी एंड दिस इज सेट एफ. सो ऑप्शन अगर हम देखेंगे तो क्या लिखा है ऑप्शन ए में, सेट ए एंड ई आर सेम. तो ए और ई सेम है, यानी यहाँ तक ये स्टेटमेंट सही है. उसके बाद क्या बोला, सेट सी एंड डी आर डिफरेंट. अब देखो सेट सी में क्या है पी और मॉड वी और डी में क्या है, डी में है मॉड वी डेल्टा. तो मॉड वी तो सेम है इन दोनों में, सेट सी और डी में, बट सेट सी में पी और सेट डी में डेल्टा है, तो सी और डी जो है सेम नहीं है, दे आर डिफरेंट सेट। तो ये स्टेटमेंट सही है, ए ऑप्शन सही है। बाकी ऑप्शंस को आप देखोगे तो बाकी ऑप्शंस गलत है। तो इस क्वेश्चन नंबर 103 का दिस द करेक्ट आंसर फॉर क्वेश्चन नंबर 103 इज ए। रिएक्टिव पावर लिमिट वॉलेट होने का पीवी बस पे जो ऑप्शंस होंगे, जो रीजंस होंगे वो क्या होंगे? अगर बहुत ज़्यादा लो वोल्टेज स्पेसिफाई कर दिया या बहुत ज़्यादा हाई वोल्टेज स्पेसिफाई कर दिया, उस केस में रिएक्टिव पावर जो लिमिट होता है पीवी बस पे वॉलेट होता है। तो इसके लिए जो ऑप्शन होगा सी ऑप्शन होगा, 104 के लिए सी ऑप्शन होगा। बहुत डिटेल में तो नहीं जा सकते, बट अगर पीवी बस पे रिएक्टिव पावर जनरेशन का लिमिट वॉलेट हो रहा है तो उसका एक रीज़न क्या होगा? अगर आपने बहुत ज़्यादा कम वोल्टेज स्पेसिफाई कर दिया या बहुत ज़्यादा हाई वोल्टेज स्पेसिफाई कर दिया, उस केस में रिएक्टिव पावर जनरेशन लिमिट वॉलेट होने के चांस होंगे। सो करेक्ट आंसर फॉर दिस 104 इज सी। हाँ, ये क्वेश्चन नंबर 105 में इन्होंने बी पॉइंट पे पूछा है। ये बी पॉइंट अगर आप इसको ध्यान दो, पावर एंगल कर्व में इन्होंने कहा है कि हमने शॉर्ट पावर को सडनली बढ़ाया, तो पहले यहाँ पे ये ए पॉइंट पे पहले ऑपरेट कर रहा है और अचानक से इन्होंने बढ़ा के शॉर्ट पावर को पी नॉट से बढ़ा के पी एस कर दिया। ये पॉइंट को उन्होंने बी पॉइंट कहा है। और जब ऑसिलेशन हो रहा है ए से लेके बी तक गया है, बी से लेके फिर सी तक गया, तो सी पॉइंट ये है। तो अगर आपसे कोई पूछेगा कि बी पॉइंट पे, इन्होंने बी पॉइंट पे पूछा है, कौन से पॉइंट पे? एट पॉइंट बी यहाँ पे पूछा है, यानी बी पॉइंट पे क्या कंडीशन है ये पूछा है। तो बी पॉइंट पे आप देख सकते हो कि शॉर्ट पावर और इलेक्ट्रोमैग्नेटिक पावर दोनों सेम है। सो बी पॉइंट के लिए करेक्ट आंसर होगा ए। फिर इन्होंने कहा है कि जनरेटर के लिए एसिलेटिंग टॉर्क, तो इतना तो सब जानते होंगे जनरेटर के लिए एसिलेटिंग टॉर्क क्या होता है। जनरेटर के लिए अगर हम एसिलेटिंग टॉर्क की बात करें तो वो होगा शॉर्ट पावर माइनस इलेक्ट्रिकल पावर। सो टी एस माइनस टी मीन्स ऑप्शन नंबर ए।
Okay.
अच्छा ठीक,
right. So here whenever you are discussing about what are the advantages of using higher power factor, in that particular case what the current which is flowing in the line is generally given by I equal to P by V cos phi. So if the power factor is more, then current drawing by this current passing through the line will be less. This is one advantage. Another advantage, think of the power loss is actually given by I square R. In that case also, if the current is actually less means power loss will be less. So higher power factor having the advantage of current through the line will be, magnitude will be less, one point. Another one is power loss will be less. So according to this one, here is for the same power to be transmitted in the current rating of the system is reduced, and also copper losses in the AC lines is also reduced. So this is the one reason. Another along with this one is the stresses in the thyristor and damping circuits also getting reduced if the power factor is also more. That is actually having a better idea, and more is reactive power requirement will also getting reduced on the thyristor based. So that answer for this question is D is the answer for this one. Question number 107, answer is D. Okay. Yeah, in case of hydro turbines, generally we are having two types of turbines, impulse turbine and reaction turbine. In case of reaction turbine, it is mainly depending on pressure drop, and actually whatever the water flow is actually direction getting changed. That is mainly depending on the combined forces of pressure and moving water, that is actually kinetic energy point of view. So that reaction turbine, what is asking in the question, pressure drop is asking, for this pressure drop point of view which is used is reaction turbine is actually used. So the answer for this one is B is the answer. One more, SVC, static var compensator. So in case of static var compensator, mainly used to control the reactive power so that voltage can be controlled. So finally you should maintain unity power factor in the system so that complete reactive power getting compensated. The advantage of using this SVC is instantaneously you can able to control the reactive power by controlling the proper thyristor firing angles, and as well as inductor and capacitor are can be taken into service, it can able to supply the required amount of reactive power, voltage will maintain constant, power factor will maintain constant. So that the answer for this one is unity power factor. That is actually is usually designed to operate at unity power factor. That means we will try to maintain that as unity power factor. Okay. Yeah, these are the questions related to the both the parts of the power system 1 and power system 2. So now next subject will continue. Thank you.
So एक और क्वेश्चन पावर सिस्टम से रिलेटेड है, क्वेश्चन नंबर 99। क्वेश्चन नंबर 99 में इन्होंने कहा है कि अल्टरनेटर के लिए कौन से इम्पीडेंस मेजरमेंट के लिए हम सीरीज़ में कनेक्ट करते हैं वाइंडिंग्स को। तो डिटेल में तो नहीं जाएंगे, बट आप अगर थोड़ा सा भी पढ़ोगे सीक्वेंस इम्पीडेंस मेजरमेंट अल्टरनेटर के लिए, तो उसमें आपको समझ में आ जाएगा कि जीरो सीक्वेंस मेजरमेंट के लिए होता है। तो क्या लिखेंगे? क्वेश्चन नंबर 99 का जो आंसर होगा ये जीरो सीक्वेंस मेजरमेंट के लिए। सो फॉर द क्वेश्चन नंबर 99 करेक्ट आंसर is C, zero sequence impedance. जीरो सीक्वेंस इम्पीडेंस मेजरमेंट के लिए हम लोग सीरीज में वाइंडिंग को कनेक्ट करते हैं। तो बाकी नेक्स्ट सब्जेक्ट स्टार्ट होगा। थैंक यू।
Hello students, this is Sagar. I am going to discuss computer fundamental questions. This is the question. When we see the question, processor runs at 200 megahertz. So here we just calculate the cycle time. Cycle time is inversely proportionate to clock frequency. So 200 megahertz clock frequency given. So cycle time equal to 1 by 200 megahertz seconds, right? This is equal to 0.005 microseconds. So first clock frequency given, we need to calculate the cycle time. Cycle time is 0.005 microsecond. Next, different instructions present in the program given. Instruction count is given in the millions and cycle per instruction given. So first we need to calculate average instruction execution time. Later we need to find out the MIPS rate. Okay. So average instruction execution time equal to time required per program divided by instruction count, right? So this is just to take the number of instructions, 8 instructions, arithmetic and logical, 1 cycle, plus 4 instructions load and store, taking 3 cycles, plus 2 instructions branch, taking 4 cycles, plus 4 instructions others, taking 3 cycles. The overall cycle time is 0.005 microseconds divided by number of instructions in the program, 8 plus 4 plus 2 plus 4. Okay. So time required for the program divided by number of instructions in the program, right? So compute this. Computational value is 0.01111 microseconds. So this is the average instruction execution time, right? So one instruction takes this much time to complete. So one instruction takes 0.01111 microseconds. So how many number of instructions are executed in 1 second, right? So this is equal to one instruction upon 0.01111 microseconds, right? So calculated value is 90 MIPS. So MIPS rate of the system is 90. Okay students, so this is the solution with respect to this question. Okay, this question we already solved in the classroom program, so already present in your running notes also. So answer is A. MIPS rate is 90. Clear? Right. Next, computer fundamental next question is, what is the exponent length in bits IEEE double precision format? Okay, this is also straightforward question present in the running notes of your classroom program. Okay, this is a 64-bit. Double precision is nothing but a 64-bit format. In the 64-bit format, total we have a 3 fields: sign, biased exponent and mantissa. Sign is 1 bit, biased exponent is 11 bit, and remaining 52 bits are allocated for the mantissa. So this is the 64-bit format. Okay, so question is what? Simply question is, how many bits are required to represent the exponents? Exponents representation number of bits are 11. So according to the option, correct answer is D. D is the right answer, 11 bits. Okay students. D is the right answer. Right. Next question. Computer fundamental. Next question is, which of the following instruction formats designed to be large scale time shared system with an emphasis on making the system easy to program, even if additional hardware expenses was involved. So when we see the differences between general purpose computer and large scale real time systems, in the general purpose computers PDP-8 format is used. In the large scale real time systems PDP-10 format is used. It is a direct theory based question. So general purpose computers uses PDP-8 and large scale time shared real time systems uses PDP-10. So answer is B. Theory based question. So that answer is B. Right. This is the next question in the computer fundamental subject. See that question. Which of the following statements is correct for machine parallelism? So parallelism is nothing but a more than one instruction execution at a time. Okay, two or more instructions execution at a time. That is called as the parallelism. Okay, so when we see the options according to that concept, okay, exactly C is matching. You see this? It is determined by the number of instructions that can be fetched and executed at the same time, and by the speed and sophistication of the mechanisms that the processor uses to find independent instructions. Yes, so this statement is exactly matching to the parallelism. Parallelism is nothing but a two or more instructions execution at a time. Okay, multiple instructions are fetching and executing independently. That is called as the parallelism, right? So according to that concept, correct answer is C. C is the right answer. Okay, students, right. Next question. Yeah, next question in the computer fundamentals is on the screen. You just see this. Consider main memory consisting of 4 kilo blocks. See this. Number of main memory blocks given in the question is 4 kilo. 4 kilo blocks are present, and cache memory consisting of 64 blocks. That means number of lines in cache memory, that is equal to 64, and block size of 32 words. So block size given 32 words. Okay, compute the number of bits in main memory address. So we need to find out the main memory address size using direct mapped cache. Actually, direct mapped cache is an extra parameter that is not involved in the solution. So simply we are calculating the main memory address size. So main memory address size depends on the main memory capacity, right? So main memory size equal to number of blocks in main memory into block size. Number of blocks in main memory into block size. Okay, so number of blocks 4 kilo blocks into block size 32 words. So this is equal to 2 power 12 into 2 power 5 words, right? So total this become 2 power 17 words. That means 2 power 17 cells are there. Each cell contain one word space. So memory address size is main memory address size is equal to log 2 power 17 number of cells base 2, that is equal to 17 bit. So total 17 bit address is required to refer the main memory. Okay students, all right. So when you see the options in this, B is matching, right? Answer is B. Okay students, this is also the straightforward question in your classroom running notes. All right. Okay, now see this. This is the next question in the computer fundamental subject. Which one of the following methods is used when the processor issues an IO command, continues to execute other instructions, and it is interrupted by IO module when the latter has completed its work? Okay, actually this statement is directly the meaning associated with the interrupt driven IO. In the interrupt driven IO mode of IO transfer, CPU initializes the IO command to the IO module. Later CPU busy with other work. Okay, continuously CPU checking for the interrupts. Whenever CPU receive the interrupt, then only CPU suspend the current execution and immediately respond to the interrupts. So that is called as interrupt driven IO. IO operations are controlled by the IO module. Therefore, CPU utilization is efficient compared with the programmed IO mode. Okay students, so in this context, which of the following modes are suitable for the above action? Okay, directly the answer is interrupt driven IO. In the interrupt driven IO, CPU continuously checking for the interrupts. Whenever interrupt occurred, then only CPU stop the current execution and immediately servicing the interrupt. Okay, so in this question, correct answer is interrupt driven IO. A is the right answer. Okay, right. So next question in the computer fundamental, that is directly conceptual question. Simply they are asking which of the following statement is correct for atomic data. Atomic data is nothing but a small data, okay, which is does not having the further decomposition. Atomic data means final data which is does not have the further decomposition, right? So for example, data types, when you see the atomic data types, primitive data types, integer is a primitive data type, okay, right, float is a primitive data type, okay, character is a primitive data type. That means atomic data is nothing but a data which is not having the further decomposition, final meaning. Okay, so in this context, if you see the options, the correct answer matching is D. It is a data that consists of a single piece of information, that is they cannot divided into other meaning pieces of a data. So D is the answer to the respective question. So D is matching with respect to the atomic data definition. Okay, atomic data means final data which does not have the further decomposition, final meaning. Okay, right. So this is the next question. Okay, students, you know, in the exam, so many questions are there from the computer fundamentals, right? As I told you earlier also, computer fundamental is a optimistic subject. Okay, so it takes less time to complete the syllabus, but it is associated with the more weightage. Okay, that's what in this exam also you have so many questions related to the computer fundamentals, right? See this. Consider 4 processes P1, P2, P3, P4. Total 4 processes given here, PID, and burst time given. Arrival time is given as 0. Right. PID, P1, P2, P3, P4. 4 processes given and associated burst times 6, 8, 7 and 3. We need to find out the average waiting time using the SJF, shortest job first scheduling, right? So first prepare the chart. Process chart always starts with 0. Okay, right. According to the given table, shortest burst time is 3. That means process 4 is scheduled. Okay, burst time is 3, 0 plus 3, 3. And next low BT is 6. That means P1, process 1. 3 plus 6, 9, completed. Next lowest BT is 7, that is P3. 9 plus 7, 16, completed. Next lowest BT is 8, that is P2. Right, 8 plus 16, 24. So this is the process chart using the SJF. Now we are taking the completion time, turnaround time and waiting time. P1, P2, P3, P4. So P1 completion time is 9, P2 completion time 24, P3 completion time 16, P4 completion time 3. So turnaround time means time difference between CT and AT. AT is already 0, therefore TAT equal to CT only, 9, 24, 16, 3. Right, waiting time is the time difference between turnaround time and burst time. So 9 minus, here given 9 minus 6, this is equal to 3. 24 minus 8, that is 16. 16 minus 7, that is 9. 3 minus 3, 0. Therefore average waiting time equal to 3 plus 16 plus 9 plus 0 divided by 4. So computational value is 7. So 7 is the average waiting time by using the SJF scheduling. Okay, students? Right. So according to the options, B is the correct answer. Okay, 7 milliseconds. Because burst time given in a form of milliseconds. Is it clear? So this is also the straightforward question which I explained in the classroom running notes. Okay, right. So next question. In the computer fundamental, next question is the processes that are residing in the main memory and are ready and waiting to execute are kept on a list called the ready queue. Okay, then this queue is generally stored as, yes, whatever the processes which are going to be scheduled to the CPU, they are keeping in a queue in a priority basis, right? Based on the arrival time, whichever the process is arrived first, that is keeping inside the queue first. So that according to the priority, processes are placed in the queue. So implementation of that queue is priority queue. So correct answer is B. B is the right answer. Okay, students. Right. So next question in the computer fundamental is, when a process creates a new process using fork. Fork is a system call used to create the processes. Okay, when you want to create new process, we are using the fork system call. Which of the following state is shared between the parent process and child process? Okay, so this is a theory based question. Direct answer is shared memory segments. Okay, so whatever the memory segments are sharing between the processes, that will be shared between the parent and child. So right answer is D. Okay, students, yeah, these are the questions which are related to the computer fundamental subject. Okay, hope you covered all the questions. Okay, you answered all the questions correctly. Okay, so I wish you all good luck. Thank you.
Hi dear students, in ESE exam I think in analog we got so many questions. Myself Adada Rajkumar and my colleague Iftikhar sir, both are going to deal the questions in analog electronics for electrical branch. I am expecting most of the students have done all the questions because they are straightforward questions. Only one question there is some ambiguity, let us discuss that question afterwards. Some questions I am starting now, after that Iftikhar sir also will take some questions.
Yes.
Question number 37, if you see 37 is a simple question actually. Statement 1, statement 2, statement 3, statement 4 he has given. According to the 37th question, option C will be the correct answer. Option C. I am giving the answer for it. Option C will be correct. You can check your answer. Option C means 1, 3, 4 statements are correct. Okay. The statement 1 is in forward bias depletion layer width will become narrower, it's a size statement. Statement 3 in reverse bias depletion region will be wider, that is also good statement. Statement 4 in forward bias majority charge carriers establish the current. Okay. Current is established, majority current will be the correct answer. So only option 2 will be the wrong answer for this. Okay. The next question we will see. Question number 38. One of the easiest question I think in your life, you have never seen this type of question. Diode current equation is asking. Whenever you start analog electronics, this is the only first equation you will see. I is equal to I naught into e power v by eta vt minus 1. That will be the answer. So I am giving the option, no need of explaining anything, directly I can give the option. Option A will be the correct answer. Okay, this is about the second question. And question number 39. Yeah, this is also very simple question. In a common emitter amplifier, the voltage gain and power gain is asking whether it will be high or low. I think in common emitter most of the times, any faculty of analog, they will explain you that common emitter is best compared to a common base and a common collector. The only main reason for it is it has a high power gain and high voltage gain. It is a very simple question. I think high voltage and high power gain. So option C is correct answer for it. Option C is correct. So these 3 questions have been completed, and 3 more questions will be started by Iftikhar sir. You can see. Question number 40.
Good evening dear students. There were so many questions from analog in electrical ESE paper, and that should have brought a big smile on your faces. Next, let me move to question number 4. The fourth question that came in analog, it is based on rectifier, half wave rectifier, and they have mentioned silicon diode, and that is the trick here. We should not overlook this part. It's a silicon diode. So we need to consider cut-in voltage of the silicon diode. For a silicon diode, cut-in voltage is 0.7 volt, and maximum load current is given. That means in this question they have provided IM, peak output current, that is equal to 20 milliampere, and they did not mention resistance of the diode. Normally practical diode may have some internal resistance also, that is not given here. So if you ignore internal resistance of the diode, then the peak current formula will be Vm minus V gamma divided by RL. Okay, here we need to consider cut-in voltage of the diode. Now from here we can find out Vm minus, I am putting V gamma as 0.7, and that is equal to Im into RL. That Im is given 20 milli and RL is mentioned 1 kilo ohm. That milli and kilo it will cancel out, and if you rearrange it, you will get Vm equal to 20.7 volt. And then we know very well in half wave rectifier, peak inverse voltage in a half wave rectifier is equal to Vm, and that should be equal to 20.7 volt. So in this way, for this question number 40, the correct answer will be option D. The important thing in this question was we need to consider cut-in voltage of the silicon diode. If you ignore that, you will get answer 20, but if you consider cut-in voltage 0.7, answer will be 20.7. So correct answer is option D. Let's move to the next question. Now this question is based on again ripple factor of half wave and full wave rectifier. We know very well for half wave rectifier ripple factor that we denote with small letter r, it will be 1.21, and for a full wave rectifier ripple factor is 0.48. Now they are asking us ripple factor for half wave and full wave respectively. So the correct answer should be 1.21 and 0.48. The correct answer will be option C. You are supposed to be careful with the options here. Option A also appears to be correct, but pay attention to the word respectively. We have to first decide ripple factor of half wave and then ripple factor of full wave. So in that way the correct answer will be 1.21 and 0.48. So I have taken here answer as option C. Then let's move to next question. Now this is based on calculation of common emitter current gain in a BJT. They have provided common base current gain. Common base current gain को हम denote करते हैं with symbol alpha, and that is given as 0.98, and we have to find out common emitter current gain. Now common emitter current gain को हम denote करते हैं with symbol beta, and that beta will be alpha upon 1 minus alpha. तो बस आप यहाँ पर alpha की value substitute करिए, you will get answer 49, beta equal to 49. So in this question common emitter current gain is 49, and hence the correct option will be option B. And the next three questions Rajkumar sir will take up.
Thank you. Thank you, sir. So these questions are looking very easy and comfortable, I am expecting. Next question will be based on 43. 43 is asking about JFET. JFET is which type of control, which type of source. Whenever we start JFET, I will say it is a voltage control current source. Why? Because the relation we have here is, for JFET, we have basic relation, ID is proportional to VGS. That means your output current, drain current will be controlled by the VGS voltage. That is why it is called as voltage control current source. This is a very basic question they have asked. Okay, I think voltage control current device, option C is correct answer for this question. Option C will be the correct answer for this, please confirm it. Okay. Next question. Yeah, this is the only question they have not properly designed according to my thinking here. See here, this total question, he said here very large VA. VA is nothing but early voltage. Again he has given some data where VA is a constant in the range of 30 to 200. They have given variation again, and they said VA is very large. According to our knowledge, when VA is very large, we try to neglect the VS. We will not consider, because any good transistor VA value will be very large. There is some ambiguity in the question. So anyway, if you use the circuit knowledge and if you solve it, let us see how the answer will come. This is the only question, you have to think like this. Threshold voltage is 4 volts, IDSS is 8 milliamperes, and VGS is 5 volts, ID is asking. Okay, they have given some information in the loop saying that ID current, VDS, RD, VDD, some information he has given. And this symbol, if you see, this MOSFET symbol is enhancement MOSFET. It is not a depletion MOSFET, please, because there is a split grid here. That means drain and source are not connected. This is called enhancement MOSFET. First of all, in enhancement MOSFET, this person should not give IDSS, he has to give some KN value. That's itself, most of the students will get confused. So sometimes in ESE exams, some mistakes or some confusions will be there in the question. So according to our IDSS equation, if you take from JFET or depletion MOSFET equation, with respect to that, if I solve it, how the equation procedure will come, we will see. First of all, a natural equation, that is ID is equal to IDSS into 1 minus VGS by VP whole square. This VP, we can take it as VT, threshold voltage, according to the MOSFET. Okay, we can take it as threshold voltage, because in JFET we call pinch off, in MOSFET we call it as threshold. This is the first equation will come into the mind for a student. The only thing is here ID is unknown, VGS is given, threshold is given, IDSS is given. Okay, ID we can get directly from this equation actually. IDSS is 8 milliamperes he has given, VGS is 5 volts, and threshold voltage is 4 volts he has given. If you apply directly the equation, you are getting the answer. But what is the purpose of taking this total loop here? Let us see. So ID, we can write it as by applying KVL at output loop. If I use this concept, output loop equation with this data, VDD is equal to ID into RD plus VDS. I am using the given data now. VDD is equal to ID RD plus VDS. ID is unknown. First, if I can calculate VDS value, from that it is possible to find out this ID, correct. So VDS, to catch that value, what I have done is I substituted this equation here. So ID can be written as VDD minus VDS divided by RD. Okay, substituting this equation, that is equal to IDSS into 1 minus VGS by PT whole square. So with the help of this equation, the VDD given in the problem 20 volts, RD is given 5K, IDSS is given some 8 milliamperes, VGS 5 volts, threshold is given 4 volts. If you substitute this total, we can get this answer VDS. So according to this, I got a VDS value around 17.5 volts. Because this every data he has given, VDS we can solve it. After getting VDS, we can find out the ID. Because ID is nothing but here in this equation, it is VDD minus VDS divided by RT. If you can do like this, you can find out the ID value from this. This is only an approach I am giving according to the given information of the circuit. I do not know what is, how he designed the question, because here VA constant and he said very large, and again he has taken the data there. So anyway, this procedure you can do it like this. Let us see how his key will be. In future we will see that answer. Anyway, according to this question, I am getting 0.5 milliamperes. This is the only question is looking improper for me in the design. Okay. Anyway, according to this, I am getting 0.5 milliamperes for this. So in the option also he has given. So option B is looking correct for this question. Okay. There is some ambiguity also in this question. The next question we will see. Question number 45. It's looking, I think he concentrated on the symbols also. IS engineering service. He has given the JFET symbol he is asking. JFET, MOSFET symbols are different. Most of the students when they started JFET or MOSFET, they can understand it. In JFET, the arrow indication will be from the gate. If it is a MOSFET, the arrow indication from the source. So by seeing this only we can tell this C, D are wrong answers, only B or A can be correct. If it is a N channel, if it is a N channel FET, if it is a N channel FET, the symbol will be like this. This is a drain, this is source, this is gate. That means the arrow should be going towards the junction, we call it as N FET, N channel JFET. It is a P channel JFET. If we get P channel JFET, P channel JFET, the arrow will be outside. This is drain, source and gate. According to the question, I think he is asking P channel JFET, so arrow should be out. So arrow is out in the B option, so option B will be the correct answer. Option B will be the correct answer. Next three questions will be dealt by Iftikhar sir. Okay.
Thank you, Rajkumar sir. The next question is based on MOSFET FET amplifiers. They have asked here properties of common source, common drain and common gate amplifiers. If you look at statement 1, it is about input resistance of common source and common drain. Now dear students, you must be knowing for common source and common drain amplifier, for common source and common drain amplifier, अगर आप input resistance लिखते हैं, it will be parallel combination of R1 and R2. Okay, as you know, in these FET amplifiers we may use divider bias, okay, voltage divider bias, which will be like in this way. It will be connected to VDD. these are resistances R1, R2, and when we do its small signal AC analysis, those R1, R2 appear in parallel between gate terminal and ground. I mean R1, R2 appear in parallel between input node and ground, and this parallel combination becomes input resistance for common source and also common drain amplifier. So in this way statement 1 is correct, okay, statement 1 is true. Then statement 2 talks about the voltage gain for common drain. Now please remember, common drain amplifier will have a voltage gain approximately equal to 1. Common drain is also called source follower. Common drain similar to common collector amplifier, we can call them source follower, emitter follower. They will be having a voltage gain approximately equal to 1. Now statement 2 tells this only, common drain configuration voltage gain is generally less than unity or nearly unity. It will be slightly less than 1, okay, or approximately 1. So statement 2 is also true. Statement 2 is also correct. Then look at statement 3, that is about common gate amplifier. Now common gate amplifier current gain will be approximately 1. Current gain approximately equal to 1. Common gate amplifier and common base amplifier, they are similar. They will be having approximately unity current gain. It will be slightly less than 1 or approximately equal to 1. So statement 3 is also correct. For common gate amplifier, current gain cannot be larger than unity. That is perfectly correct statement. Statement 3 is also correct. So in this question, all 3 statements are correct. So the correct option should be 1, 2 and 3. I am taking here answer as option D because all 3 statements are correct. Then let's move to the next question, which is based on feedback amplifier concept. And we tell in the classes always that feedback is an important topic with respect to ESE. And this year they have asked 2 questions from feedback topic. Okay, let us look at this question. An amplifier has a bandwidth 500 kilohertz and a voltage gain 100. What will be amount of negative feedback if the bandwidth is extended to 5 megahertz? Now to solve this question, we can simply use bandwidth formula. When we use negative feedback, then bandwidth of a feedback amplifier, it will be bandwidth without feedback into 1 plus beta into A. Okay, everybody knows this formula. Bandwidth of a feedback amplifier is equal to bandwidth without feedback into 1 plus beta A. अब आप यहाँ से 1 plus beta A कैलकुलेट करिए. 1 plus beta A is equal to BWF divided by BW. That BWF is given 5 megahertz and bandwidth without feedback, that is given as 500 kilohertz. अगर आप इस रेशियो को फाइंड करेंगे, it will be equal to 10. 1 plus beta A is equal to 10. अब हम यहाँ से बीटा फाइंड कर सकते हैं. बीटा इंटू A is equal to 9 और बीटा is equal to 9 divided by A. That A is given as 100 here. So 9 divided by 100, I am getting feedback factor beta equal to 0.09. So in this question they are actually asking feedback factor beta only, which is given here as amount of feedback, but normally we call it feedback factor beta. So the correct answer in this question will be 0.09. We can take the option as option C. So this was question on feedback. Then we have one more question on feedback concept. An amplifier has open loop gain 1000. If 10% voltage series feedback is used, then what is closed loop voltage gain? It is again a direct question. Beta is given. Beta is 10%. Now that is nothing but 0.1. 10% negative feedback is used. It means beta is 10% or beta equal to 0.1. Then we can apply the formula of gain of a feedback amplifier, AF equal to A divided by 1 plus beta into A. अब आप यहाँ पर ओपन लूप गेन सब्स्टिट्यूट करिए. ओपन लूप गेन का मतलब होता है गेन विदाउट फीडबैक, विच इज 1000, ओके, डिवाइडेड बाई 1 प्लस बीटा यहाँ पर है 0.1 इंटू ओपन लूप गेन 1000. अब आप यहाँ से क्लोज लूप गेन या गेन विथ फीडबैक फाइंड करिए. इट विल बी अप्रॉक्सीमेटली 9.9. सो इन दिस क्वेश्चन द करेक्ट आंसर विल बी ऑप्शन सी. So these were two questions based on feedback amplifier, and there are some more questions which will be taken up by Rajkumar sir.
Yeah, thank you, sir. I think two continuous questions on feedback, okay, based on the formulas AF is equal to A by 1 plus A beta. That's great. Question number 145, 146, 147, 3 questions straightforward they have given in assertion and reasoning. The 3 questions I am dealing. Question number 145. I think before that there is some 124 question is also there, which is I have taken in analog because this is from band pass filter. In active filters we have the filter formulas. Networks people also can solve this. So first of all, what is the value of quality factor if the band pass filter is having frequencies of 800 to 1200 he has given, okay. First of all, band pass, there are two types of band pass, this is one and this is another one. First a student should know this logic. We have wide band pass, we have narrow band pass. Wide band pass, narrow band pass, this is your cutoff frequencies, one is FL and one is FH, and here also we have FL and FH. So by seeing these two waveforms you can understand this is a narrow band because FH and FL are very close to each other, and FL and FH are very far away, we will get the wide band pass. But a student should understand here, if FL and FH are very close to each other, we are going to take the average to get the center frequency. The formula here is center frequency is FH plus FL divided by 2. For narrow band pass, to calculate the center frequency, this is the formula because quality factor formula is FC by bandwidth. Your quality factor formula is center frequency divided by bandwidth. So here the confusion for the student is which formula we have to use. This is for narrow band pass, okay. If you are having a very wide range, we go for geometric mean method. So FC center frequency, we can calculate it as FL into FH. So how to decide it, whether the given values are in wide band or narrow band. This is your narrow band. There is a condition for this to understand whether it is a narrow band or not is FH divided by FL. If it is less than 1.1, with this ratio, if it this ratio whatever you are calculating comes less than 1.1, you can say this is a narrow band. If your FH by FL, higher cutoff frequency by lower cutoff frequency, if it is greater than 1.1, you can go for wide band. According to the given data, FL he has given some 800 and FH he has given 1200. So if you see 1200 divided by 800, if you do it, we are getting 3 by 2, which is 1.5. So it is selecting this condition. So if you know this logic, you can find out the FC value. From the networks also, I think you have these formulas with you. FC formula will come directly by these two frequencies under root. That FC answer how much I got value, just 1 minute. Here is that solution. Yeah, I got around FC answer for this is 979 Hertz. 979 I got because of this formula. When this is 979, the quality factor FC value I can write here 979 Hertz divided by bandwidth. Bandwidth is nothing but FH minus FL, that is 1200 minus 800, it is 400. So it will be 400 Hertz. So the answer will come around 2.45. So this is the answer. According to the option B is correct answer. Option B is right answer for this. So 2.45 will be the correct answer according to this question. Okay. The next question will be what is this?
145. 145.
Yeah. The next question will be 145. The statements are with me. 145. Yeah. There are two statements he has given. Diode designed to operate in forward bias region are called Zener diodes. Everybody knows that this statement is not correct. Zener diode always operate in negative region, that is in the quadrant number 3, okay, that is in reverse bias condition. So, statement 1 is false. Statement 1 is false. It is very clear to tell the first statement is false. The second statement is said that the principal operational region for a Zener diode is negative in terms of both voltage and current. Yes, statement 2 is true. Why? Because if you see the graph for Zener diode, the voltage and the current both are in negative side. So, both quantities will be negative. This is the Zener graph. So, statement 2 is correct as statement 1 is false. So, what will be the correct answer for this is, what is the option? D. Statement 1 is false, but statement 2 is true. So, option D will be the correct answer for this. Option D will be the correct answer. Okay. This is about 145 question. What about the next question we have is 146 we will see. This is also assertion and reasoning, continuously 3 questions he has given. 146 question, if you see the first statement, a small signal equivalent circuit of BJT or NPN or PNP whatever may be at lower frequencies will be ignoring capacitive effects. This is very simple question, I think. Statement is clear. In any small signal analysis of BJT, it can be NPN or PNP. In small signal model, we will not consider the junction capacitances. Junction capacitance will be considered only in high frequency model, that is called pi model theory. So, this statement is perfect, this statement is true, perfect. Second statement you observe it, despite the structural similarities, a PNP BJT has higher current gain than NPN BJT. The statement is not looking correct because NPN transistors will have more current gain compared to BJTs or PNP. The main reason for that is the mobility of electrons will be more than the mobility of holes. Okay. A statement they have given reverse, it is a false. Yes, given PNP has a more current gain, we cannot accept that. So, first one is true, second one is false. So, I think for this option C will be the correct answer. Option C will be the correct answer for this 146 question. Coming to the 147, this is the last question. Let me complete that question also. There is a final question for you. This question can be solved by digital electronics faculty also, analog electronics faculty. Anyway, we kept in our site. Statement 1, he said that MOSFETs are preferred over JFETs in digital integrated circuits, saying that they are used in digital electronic circuits. A very simple reason, according to analog electronics concept, a JFET will always work in depletion mode. A depletion mode type of devices cannot work like a switch. They are not a good switches. But whenever in MOSFET, if you consider, we have depletion and enhancement also. The enhancement MOSFET can work as a good switch because it will operate in an enhancement position. The diode is a good switch actually because it works as an enhancement. So, that is the main reasons why MOSFET will be shifted in digital electronics compared to JFETs. So, say this answer is perfect, this is true, perfect. And the second statement, if you see the usage of P channel MOSFET as an active load for a N channel MOSFET leads to a logic family called CMOS. I think every student knows this concept. A CMOS is nothing but a complementary MOS transistor which is having 2 transistors, one is NMOS, one is PMOS. NMOS is kept in the bottom, PMOS is kept in the top, where PMOS will work as an active load for us. Okay, it is a perfect statement. This is also true. Both are true statements, so there is no doubt about it, but there is no link between these two things. The first one is talking about MOSFET to JFET comparison, second one is telling about the CMOS. So, there is no link. So, option B will be the correct answer. Both statements are correct, okay, but reason is not there. So, option B will be the correct answer. Option B will be the correct answer for question number 147. Okay. Now, I think Iftikhar sir, The question paper is very easy.
Yes,
I'm
sir.
expecting.
Yes, sir.
Comfortable for the students.
I think
they can write.
most of the students must have done all these questions, and that shows importance of analog in electrical engineering.
In electrical, I think every year I'm seeing nearly 15 to 16 questions are coming. That means around 15% to 10% mocks are there.
Yes, sir.
If they just read the notes, they can do all these questions. I'm
Yes,
expecting.
yes.
Anyway, thank you very much. I hope you have done well. I'm so happy by seeing these questions. Most of the students, if they do some silly mistakes, I think the rank will not be decided for them, because there are some confusion questions. Half wave rectifier, full wave rectifier, one question we have seen.
Yes, yes.
In that ripple factor, they are asking one of the easiest questions.
Option A and C were very similar.
When I got some question paper, one student has written option A. It's a simple question and they will do some mistakes. Okay, anyway.
In exam tension, we commit such mistakes, but when we look at options, we should not hurry up.
Yeah.
Okay.
You have to do cool. Anyway, most of the students have done well, electrical engineering students, I'm expecting. Thank you very much. Yeah.
Yes, dear students, thank you. Thanks for your patience. And please wait for the next subject.
Yeah. Thank you.
Hello my dear students. So as far as power electronics is concerned, questions 11 questions they have asked. So questions are almost moderate and easy questions when you compare with the gate questions. Okay, So first 4 questions Sajal sir will handle and remaining questions I will handle. Okay. So first let me handle question number 113. In a single phase full wave controlled bridge rectifier with source inductance and RL load. So here due to source inductance during overlap period all the 4 thyristors are conducting in the case of a bridge rectifier. When all the 4 thyristors are conducting, the load terminals across the DC will be shorted. So output voltage will be 0. So during this interval the output voltage is 0. Okay. So answer to this question is option C is the right answer, 0. Okay. So the next question. In a step down chopper operates in a continuous conduction mode with a duty ratio D. So we have to find the ripple factor. Ripple factor in the sense for voltage waveform. For output voltage waveform, we have to find out the ripple factor for output voltage waveform. So here step down chopper in the sense, you may have a doubt in this case, is it with filter or without filter? If you consider filter with high capacitance across the load, then output voltage is almost constant, then in that case ripple voltage is 0. So that option is not given. So that means it is by default understood that it is without a filter capacitance, right? So in that case the output voltage waveform is like this. So when the switch is on, output voltage is Vs during the interval T on, and when you disconnect the switch during freewheeling period, the load voltage is 0, right? So in this case RMS value average voltage is D into Vs, where D is equal to T on by T, which is the duty ratio of the switch, and here RMS value of output voltage is square root of D into Vs. So for this form factor is the ratio of RMS voltage by average voltage. So square root of D into Vs, here alpha means D here, by D into Vs. Okay. So that comes to be 1 by square root of D. So that is the form factor for this voltage waveform. So voltage ripple factor in terms of form factor is square root of form factor square minus 1. Just substitute the form factor in this equation, you will be getting 1 by D here, capital D, minus 1 under root. Okay. So if you simplify here, 1 minus D by D under root. So just multiply by D in the numerator and denominator, it becomes square root of D minus D square by D. Okay. So answer to this question is option A. Just very simple here. Okay. So then next, I hope it is clear. So go through the next question. When a separately excited DC motor is controlled from a 3-phase AC source and it is to be operated only in the first quadrant, and which of the converter is used? So if you go through the 3-phase dual converter, it will operate in all the 4 quadrants. So that is the wrong. And 3-phase semi converter, definitely it will operate only in 1 quadrant, and full converter operates in 2 quadrant, right? So answer is option B. Okay. Very simple question. Then the next one is a wound rotor induction motor. It is actually a slip ring induction motor. Asynchronous motor is nothing but a slip ring induction motor. And what type of applications we are using for this drive? For overhead cranes. You can see the application, overhead cranes and load equalization. So here it is a slip ring induction motor. So here we use static rotor resistance control. In the case of static rotor resistance control, by controlling the duty ratio of the switch, we can effectively control the rotor resistance which is connected in series with the rotor, and accordingly we can control this. Okay. So option B is the right answer in this case. And the next question, which one of the following statements are correct in a series resonant inverter? So here resonant inverters or resonant converters, we can operate in 2 ways. One is ZCS or ZVS. So 2 methods we can operate. In the case of series resonant inverter, here the load voltage is of a rectangular waveform. the load voltage does not depend on the load parameters. So if you see here, the load voltage is rectangular waveform, it is not square wave, it is actually a rectangular waveform, depends on the time period. So here the output voltage will not depend on the load parameters. So option D is the right answer for this question. I hope you understood. The next question, which of the following switching techniques is commonly employed in resonant converters? Just now I said zero voltage switching and zero current switching technique, ZVS and ZCS. Option C is the right answer here. Okay. So I hope all questions are clearly discussed in our regular course. Even average students can easily answer most of the questions. 95% of the questions they can answer. Okay. So you will see this question, the function of a static transfer switch. So what is the role of a static transfer switch in UPS? See, in the case of an UPS, here suppose we are having a primary source supplying power to a certain critical load, right? So whenever there is certain interruption of power from the primary source due to various reason, immediately we have to switch the power to the secondary source. It may be we are supplying the power from a UPS, so switching should be faster from one source to the another source and then connect to the critical load. So in that concern, if you see the option A, the power supply to the critical load, okay, from UPS to power line and vice versa. Here if you see here, what is the role of static transfer switch? Switching is done from UPS to power line or power line to UPS, and vice versa can be written here. In fact, option A is the right answer in this case. Okay. So right students, remaining 4 questions our Sajjal sir will handle, right? Thank you very much students.
Thank you, sir. So, good evening all. I hope you have performed very well. Let's discuss few questions. In this particular question, the question is question number 109. By considering the standard notations, reverse recovery time TRR. We all know the reverse recovery characteristics. With respect to that, we are going to proceed further. So what we know? We know very well that QR. We know very well that the QR is equal to what? 1 by 2 multiplied by TRR multiplied by IRM. This is our equation number 1. And we all know very well that di by dt is equal to what? IRM divided by TA. Yes, in general we consider as per the given information that TA is approximately equal to TRR. So what can we say? We can say our di by dt is equal to IRM, obviously approximately equal to, but we are going to consider directly the equal to sign. So if we observe here the IRM, what do you mean by IRM? With respect to the given option, we generally choose in what way we have to proceed. So here IRM is equal to what? TRR into di by dt. If you observe equation number 1, so what can you say from equation number 1? From equation number 1, what can we say? The QR is equal to 1 by 2 multiplied by TRR, and obviously this part is going to be in the multiplication, so square into di by dt. So in which form the examiner has given us the option? In the form of TRR. So from this we can say TRR is equal to what? Under root 2QR divided by di by dt. So which option is available to us? The option 2QR divided by di by dt. TRR is equal to under root 2QR divided by di by dt. This is very normal question which was already asked many times in the previous years. So I hope you all have marked this particular question. Okay, now come to the next question number 110. This is the definition based question, that is overdrive factor. For this particular question we can directly say the overdrive factor is nothing but IB divided by IBS, that is option B. Let's come to the next point. This question is directly formula based, so we will not give too much time there, already covered in the syllabus during the classroom course. So now come to the next question, that is 111. when the amplitude of gate pulse, okay, let's take this, it is from the static characteristics, amplitude of the gate pulse to the thyristor is increased. What happens? Yes, we all know very well the delay time corresponding to this situation reduces. Okay, delay time would decrease. Okay, delay time would decrease. Now come to the rise time. You know what? In general, the rise time depends upon the load. Okay, in general textbook we observe the author may write that TR will also reduce, but I must suggest you, as per the option also, that TR reduces is not available. Okay, and by logic it's also true that almost we can say unaffected situation with respect to the rise time. So don't worry about that. Obviously that conflicting option is not available. Directly we can hit the option C as the answer of this particular question. So come to the last question of this particular beautiful subject, that is power electronics. Question number 112. A single phase full wave bridge rectifier. Okay, it's what? Single phase full converter. Circuit is fed from 220 volt, means definitely our VM is equal to what? 220 root 2 volt. Okay, come to the next point. It consists of 4 diode, means operation will be uncontrolled. Okay, there is no need for the consideration of alpha and all, means we can consider alpha equal to 0 and we can proceed further. Load resistance they have given R is equal to what? 20 ohm. Okay, very large inductance, a very common sentence with respect to that. Obviously we know the load current remains ripple free, that is constant. So what is the question? The question is, what is the average or DC output voltage? Very simple question. We can directly say V naught average is equal to what? 2 Vm upon pi. We will put all the values, that is Vm is nothing but what? 220 root 2 divided by pi. Once we calculate this, it will come something very approximate near value, that is 198.165. I have calculated that nearly this only. So we can say the option C is the correct answer of this particular question. Like this almost we have solved each and every question. So I hope you all have performed very well in this particular part. For the rest subjects, I welcome my colleague. They will consider the other questions with respect to their subject. Thank you.
Hello dear students, let us discuss the question from microprocessor. Let us see question number 1, which was given like 129th question. So according to the description of the AND instruction of 8086 microprocessor, what are the essential conditions to be satisfied while executing it? So AND is actually a bitwise operation, okay. So in this 8086 microprocessor, which is a 16-bit microprocessor, so what are the different operations which can be, what are the essential conditions that can be satisfied? The first one, look at the first one. So if you observe the first one, so first one, the source can be a register or a memory location, that is correct. The destination can be a register or memory, that is also correct. So here the main thing is that it can operate either byte or word. So you must see that the third one should be satisfied. So third one is required. So because AND is a bitwise operation, is it clear? So either you can operate like for example say ANA AND operation between two 8-bit registers or some words also, is it clear? Means 16-bit also. So therefore you have to see that both of them are of equal type, either bits or bytes or words, okay. So therefore third one should be true. So if you observe here in the first two operations, third is not there. So these two are wrong answers. So these two are wrong answers, eliminate them. So what could be the correct one? Either C or D. But observe here, so both of them having 1 to 3 commonly. So just look at about this fourth one. So the source and the destination cannot both be memory locations in the instruction. It means that it can support source and destination both register or memory, but provided that in the instruction both of the source and destination cannot be memory locations. So that is true only. So therefore all this 1, 2, 3, 4 are all of these are correct. So option is C for question number 129. So if you look at next question, which is something like a common question for processor and computer fundamentals, look at the question. So in this question number 36, if you observe question number 36, so it says, it's a theory question, which one of the following is used for recognizing the magnetic encoding numbers printed at the bottom of a check. So generally if you take a bank check, if you take a bank check, it will have different codes, like it will have some MICR code, okay. So it will have some MICR code. So this is MICR. So MICR stands for what? Magnetic ink character recognition code. So this is meant for this, called as what? Magnetic ink character recognition, okay, fine. So this is actually a 9-bit code, 9-digit code, 9-digit code. So this 9-digit code indicates what is the city of the in which the bank is present, and what is the bank code and what is the branch, okay. So that is for avoiding the duplication of these checks or to avoid the frauds. So that is magnetic ink, which is not easily captured or taken care by this fraudsters, is it clear? So that is why this MICR code reader will be there. So therefore it is a direct question, theory question. So it is, first one is OMR, it is wrong. Magnetic ink character recognition, barcode reader, optical character recognition. Therefore the answer is option B, magnetic ink character recognition. So 36 one is B. So because first one and optical mark recognition, that cannot be true, barcode reader it cannot be true, and last one is optical character recognition. Is it okay? So therefore the answer is MICR. So magnetic ink character recognition reader will be there. So that is the answer. So 36 will be option B. Okay, fine. Thank you.
Good evening all. Let us take up control system solutions now, solution for the control system questions. I am confident that you all might have done very well, because out of this 13 questions, most of the questions are from either from the previous papers, or they are from the classroom notes, or from the ESE material somewhere, either from the theory book and mostly from the workbook. All the questions are easy and simple and straightforward. You might have not faced any difficulty, particularly those who happen to be students of ESE, who studied with ESE. So it's very easy. Let's take those questions now. See this question. Consider the following condition for a second order system when subjected to unit step input. With critical damping, there are no oscillations. Critically damped zeta is equals to 1, whose response is non-oscillatory. We see that in notes, okay? Non-oscillatory response. This is critically damped. This statement is true. Second statement, with no damping, the system output oscillates with constant frequency and variable amplitude. This statement is false, because with zeta 0, we know that the response of the system is this. It has got constant envelope of amplitude, but frequency, constant frequency. No damping, undamped system. The system output oscillates with a constant frequency, that's right. The frequency of oscillations is omega n, and a variable amplitude. ये false है, क्योंकि the difference between undamped system and underdamped system is, in case of underdamped system, that system will have constant frequency but variable amplitude. It is the underdamped system which has constant frequency of omega d but variable amplitude. Undamped system has got constant frequency and constant amplitude, whereas critically damped system has zero frequency and amplitude, of course, that is finite. Not just, we cannot say constant. Overdamped system, not at all concerned with oscillations. Third statement, with overdamping, the output takes longer time to reach to steady state. Overdamped system physically second order but functionally first order, because of the dominant root whose time constant is going to be huge, the system tend to become sluggish. Obviously it will slow down. That is a true statement. Answer to the question is 1 and 3. In this question, the Nyquist stability criteria, the closed loop system whose open loop frequency response as omega varies from 0 to infinity do not encircle minus 1 comma 0 point, then what will be the stability of the system? See, it is mentioned that Nyquist plot, polar plot is part of the Nyquist plot. It is mentioned that it does not encircle minus 1 comma 0. It is mentioned that it does not encircle minus 1 comma 0. So we can say that it is to the left side of the polar plot, or it is the outside of the Nyquist plot. That means n is equals to 0, and by default p is equals to 0. If nothing mentioned, that number of open loop holes in the right side of his plane, p is equals to 0. That means n is equals to p. We can declare the closed loop system to be stable. Moving to this question, which of the following will be the error time graph related to the integral controller output? Which error time graph is relevant to the following integral controller output? We know that output of integral controller is some constant ki integral 0 to t e of t dt. It means what? Whatever be the input, the output becomes same as the input over a period of time through accumulation or integration process. If the input given to the controller is a constant, integral controller is step, then its output will be ramp. If input is ramp, output is parabola. If input is impulse, then output is step, because output is integration of the input. If output is ramp, then input should be step position, constant. So of course this cannot be the option. This is step, this is not step. This is combination of two steps. It is pulse, so it can't be. And even this is also a pulse. It should be this. Actually this is of negative amplitude, then the ramp should be negative. But I mean, to be more clear, it should be a step of positive amplitude. But among the given options, the best option is option B. It should be step in nature. In this question, right, I mean that will be taken by other faculty. I mean few questions. I'm moving to the next question. Which one of the following steps is correct while plotting an open loop ब्लॉक डायग्राम बनाने में? ये जो स्टेप्स है ना, इसमें से करेक्ट कौन से हैं? correct. See, transfer function of the open loop is in constant frequency form. ये false है. इसके options कहाँ गए? Okay, fine, no problem. We have nothing to do with the options. मैं जो सही है वो गलत है वो बता देता हूँ. तो ट्रांसफर फंक्शन को जो है कांस्टेंट फ्रीक्वेंसी फॉर्म में लिखा जाएगा. नहीं, ये कांस्टेंट टाइम फॉर्म में लिखा जाएगा. राइट, टाइम कांस्टेंट फॉर्म होना चाहिए. देयर इज नथिंग कॉल्ड फ्रीक्वेंसी कांस्टेंट फॉर्म. सो अकॉर्डिंगली दिस स्टेटमेंट इज फॉल्स. स्टेटमेंट बी, फॉर द लो फ्रीक्वेंसी असिम्प्टोट इधर, अच्छा इट्स नॉट एन आई मीन ABCD में ही सही निकालना है ना. राइट, तो फॉर द लो फ्रीक्वेंसी असिम्प्टोट इफ देयर इज ओनली the proportional link, one should plot the horizontal line with the amplitude value minus 20 log k to the base 10. See, if the open loop transfer function has only a proportional link, it means only gain, that's called proportional link. Then we plot an horizontal line whose slope 0 with a magnitude 20 log k to the base 10, not minus 20 log k to the base 10. So this statement is false. Third statement, for high frequency asymptote, it means after that first plot, low frequency, zero frequency, for high frequency asymptotes, one should change the slope of the asymptote in every break frequency. This break frequency is referring to corner frequency, जिसको हम corner frequency कहते हैं बोर्ड प्लॉट का डिस्कशन में. In this terminology, because ES exam के जो language होती है ना, this is something unusual. We don't call it to be break frequency, it has to be called as corner frequency. So we need to change the slope of the asymptotic board plot in case of high frequencies for every corner frequency. Obviously, if the transfer function has got many poles and many zeros, then the corner frequencies happens to be the poles and zeros of the system themselves. So we will be changing the slope of the board plot at every corner frequency. Right, हर corner frequency के पास हम slope change करते रहेंगे. Fine, this is correct statement. Compensate the asymptote to get the precise constant time characteristic diagram. It's not the time constant time characteristic diagrams that we get. Board plot is a frequency domain technique. We actually get the frequency characteristics from the board plot, not of any time characteristics. Correct answer to the question is option C. For the closed loop transfer function, as part of necessary condition for the stability of the linear feedback system, the characteristic equation roots must satisfy the following condition. That's simple. For a system to be stable, what should be the condition? In terms of the roots of the characteristic equation, no nil roots. Nil root in the sense zero root. If there is a root of the characteristic equation at origin, that system is not stable. Yes, this is very much required. I mean, what is needed for stability? That is needed. No conjugate pure complex roots. No conjugate pure complex roots. That means geometric axis roots. हाँ, ये भी नहीं चाहिए for stability. That is very much true. All the real roots must be negative. I'm sorry. All the real roots must be negative. I consider this to be a false statement because for a system to be stable, all the roots of the characteristic equation must be negative, not just the real roots. Had it been the statement, if I treat it to be that misuse of the words, all the roots must have negative real part, then this would have been the right statement. If it says that all the real roots must be negative, this gives me the meaning that only the real roots of the characteristic equation has to be negative, whereas the complex roots of the characteristic equation, they can be anything. That's what I learn it to be from this. Accordingly, this is false statement. 1 and 2 only will be my option for that. Give me a second. Did I miss anything? 74 was discussed, right? Yeah. Okay, where are we? 79. 80. The raw array of an open loop transfer function of unity negative feedback control system is shown under. The question is, this system is stable and unstable for what values of k respectively? See, of course, for a system to be stable, all the roots of the characteristic equation, in terms of row array, all the elements of the first column of row array must have same sign and no row should become 0 completely. Accordingly, this has to be greater than 0 and this has to be greater than 0. Combinedly, -1 less than k less than 8 is the condition of stability. So, if k is either less than -8 or k is greater than 8, if k is less than -1 or k greater than 8, system is unstable. If k is equal to -1 or k is equal to 8, marginally stable. If k is anywhere between -1 and 8, it is stable. So, this value of k is for stability, and any value of k more than 8 is instability. So this is instability, this is instability. This question is something weird. I don't understand why two options are made to be satisfied for this. Both B and D suits to that. Probably what I guess, probably he is not intending for giving to be 15. It may be 5 is what I say. कोई प्रिंट मिस्टेक हो सकता है क्योंकि इस क्वेश्चन के दो ऑप्शन सेटिस्फाई कर रहे हैं, ये कंफ्यूजन जरूर आएगा एग्जाम में. तो as per the print both B and D are correct answers, but if you want me to judge this, ऐसे 5 देने के बजाय 15 दे दिया होगा उसने. तो if I make it to be 5, in that case this is wrong, then this is right. B. Which one of the following is not a method to reduce the steady state error of the system? Increasing the open loop gain will increase the open loop DC gain, will reduce the steady state error. It is a method to reduce the steady state error. So this cannot be the answer because we have to find which is not the method to reduce the steady state error. Limiting the system type will increase the steady state error. If type increases, steady state error decreases. If open loop gain increases, steady state error decreases. So definitely this is not the method to reduce the steady state error. Answer is B. Whereas controllers, compound controller matlab, it is composite controllers, PD controller, PI controller, PID controller को compound controllers कहते हैं, and they are used to reduce the steady state error. They may be able to make 0 or may not be able to make 0, but they do definitely reduce error. Feed forward controller, it may be able to make 0 error or may not be able to make 0 error, but definitely reduces error. Question is only about reducing the error, not about making it to be 0. If it is to make it to be 0, only PI or PID controllers are eligible to make it to be 0. Whereas reducing it, it can be done by increasing open loop gain or by increasing the type, not by reducing the type. So answer to the question is B. Taking up this, consider the following visualizations regarding lead compensator. Then, which of the following is a board plot of lead compensator? A, B, C. We know that lead compensator is going to increase the gain crossover frequency compared to uncompensated system. Gain crossover frequency is the frequency where the magnitude plot is going to intersect 0 dB axis. This is where this magnitude plot, plot number A is intersecting 0 dB axis, and plot C is intersecting 0 dB axis here. It means that this A is uncompensated system, C is compensated system, then B will be the lead compensator. All this is not required. A lead compensator is high pass filter. High pass filter characteristics तो यही तो है. तो अगर lead compensator का board plot है B है तो B only. That's all. Yeah, coming to the last question on my part. This is assertion and reasoning. Statement 1. The root locus is the path of the definition of root locus. It's a graphical technique that deals with the location of the roots of the characteristic equation as a function of one of the system parameters. Usually open loop gain, not necessarily. It can be any parameter of the system varied from 0 to infinity. Yeah, that's a true statement. Second statement. The frequency response of a system is defined as the steady state response of the system. First of all, this itself is the wrong thing. Right. Frequency response is not just the steady state response, is also the transient response, combination of both transient and steady state. Point number 1, case statement गलत कहने के लिए. To a non-sinusoidal input, this is the second wrong statement. Frequency response means sinusoidal response. Time response means impulse step ramp parabolic responses. तो दूसरा गलती है statement में, यानी statement false कहने के लिए. And resulting output signal for a linear system is sinusoidal in the steady state. Yeah, it differs only in the input amplitude and phase angle. This much part of it is true for frequency response of LTI system, but the remaining part of it is false, and this has nothing to do with this particular statement. कोई तालमेल है नहीं. So I say that individually statement 1 is true, statement 2 is false. Accordingly, the option has to be option C, according to that directions given. The rest of the questions will be taken care. Okay.
Okay, dear students, I hope ओके डियर स्टूडेंट्स, आई होप यू ऑल हैव परफॉर्म वेल। सभी ने बहुत अच्छा पेपर किया होगा। क्वेश्चन बहुत डायरेक्ट आए हुए हैं, बहुत टाइम कंज्यूमिंग क्वेश्चंस नहीं देखे गए हैं। कंट्रोल सिस्टम के क्वेश्चंस भी बहुत अच्छे हैं। बाकी के क्वेश्चन चलिए डिस्कस करते हैं। सभी क्वेश्चन सिंपल लग रहे होंगे आपको। आते हैं हम अब क्वेश्चन नंबर 73 की तरफ। अ नेगेटिव फीडबैक, सी कितना सिंपल क्वेश्चन है। अ नेगेटिव फीडबैक सिस्टम हैज फॉरवर्ड पाथ गेन, मतलब जी दे दिया है हमको, कितना दे दिया है 18 समथिंग, ओके। एंड फीडबैक पाथ गेन ऑफ मतलब एच कितना दे दिया है 0.15। so overall gain, oh simple question, what can we say, transfer function like that we can proceed and then we can get the gain। negative feedback system है इसलिए यहाँ पे हो गया क्या 1 प्लस जी एच। पुट करेंगे वैल्यू, कैलकुलेट करेंगे, यहाँ पर क्या वैल्यू पुट होगी 18 डिवाइडेड बाय 1 प्लस 18 मल्टीप्लाइड बाय 0.15 और कैलकुलेटेड वैल्यू मिलेगी हमें 4.86। ऑप्शन ए अवेलेबल है। इस क्वेश्चन का आंसर ए होगा। चलिए अब नेक्स्ट क्वेश्चन की तरफ चलते हैं। जैसे कि अगर बाकी हम क्वेश्चन को देखें, सो नाउ अवर नेक्स्ट क्वेश्चन फॉर द डिस्कशन इज क्वेश्चन नंबर 77। ये भी बहुत सिंपल क्वेश्चन है। चलिए देखते हैं क्या है। फॉर द गिवन ट्रांसफर फंक्शन, हमने कहा चलिए ट्रांसफर फंक्शन देख लेते हैं। ये हो गया हमारा जी एस इज इक्वल टू क्या, के डिवाइडेड बाय 1 प्लस टी एस। ओके, व्हाट इज द फेज ऑफ द फ्रीक्वेंसी रिस्पॉन्स। ओके वेरी सिंपल। तो सबसे पहले क्या किया हमने, एस को जे ओमेगा पुट कर दिया। हम आगे बढ़े, देखा क्या हुआ, के डिवाइडेड बाय 1 प्लस जे टी इंटू ओमेगा लिख दिया हमने। अगर मैं फेज जानना चाहता हूं तो ये हो जाएगा माइनस टेन इनवर्स टी इंटू ओमेगा। और आप सभी लोग जानते होंगे कि टेन इनवर्स को इन जनरल हम इस तरह से कुछ लिखते हैं, ये देखिए इस तरह से लिखते हैं। सो विच ऑप्शन इज गोइंग टू मैच, ऑप्शन ए इज गोइंग टू मैच आवर नेक्स्ट आंसर। आवर आंसर ऑफ द क्वेश्चन 77 इज ए। चलिए अगले क्वेश्चन की तरफ बढ़ते हैं। अगला क्वेश्चन जो अभी हमें डिस्कस करने के लिए बचा हुआ है वो है हमारा क्वेश्चन नंबर 81। चलिए क्वेश्चन नंबर 81 की बात करते हैं। दोस्तों ये क्वेश्चन जो है उस टेबल से रिलेटेड है जिसे हम जनरली शॉर्ट नोट में बनाया करते थे एरर के रिस्पेक्ट में। तो चलिए उसी पर्टिकुलर टेबल की मदद लेकर हम इसे आंसर करेंगे। सॉल्व नहीं करेंगे क्योंकि हम जानते हैं क्लासरूम में सब कुछ पढ़ा हुआ है। जैसे कि अगर हम देखें टाइप इंक्रीज कर रहा है, ऑब्वियसली पर्टिकुलर इनपुट के रिस्पेक्ट में क्या होता है, हमारा जो एरर है वो रिड्यूस हो रहा होता है। इन दिस पर्टिकुलर कॉलम here it must be equal to what, infinite in this particular column, and with respect to type 1 what will be the value, r divided by k should be the value। come to the last row that is system type 2, with respect to that here it should be what, 0। तो आपने ये पर्टिकुलर शॉर्ट नोट में भी टेबल को प्रिपेयर करते समय बनाया होगा। चलिए सो विच ऑप्शन इज गोइंग टू मैच, इनफाइनाइट कॉमा r by k comma 0, infinite comma r by k and 0। option A is the answer of this particular question। very simple, no need to discuss too much here। come to the next question which is now remaining to us। question number 83। consider the following statement related to root locus। बहुत सिंपल क्वेश्चन है। हम लोगों ने जो रूट लोकस को बनाने के लिए स्टेप्स को पढ़ा हुआ है, थोड़ा बहुत आइडिया हमें वहां से लग रहा है। और फिर अगर हम देखें तो देखिए स्टेटमेंट नंबर 1 क्या कह रहा है, द नंबर ऑफ ब्रांचेस ऑफ द रूट लोकस इक्वल टू द नंबर ऑफ क्लोज लूप होल। सही बात है, बिल्कुल सही बात है। स्टेटमेंट 1 तो हमारा सही जा रहा है। रूट लोकस इज सिमेट्रिकल अबाउट द रियल एक्सिस। बिल्कुल, ये कैसे होता है क्लास में हम जानते ही हैं, सिमेट्रिकल होता है विद रिस्पेक्ट टू रियल एक्सिस। ओके चलिए नेक्स्ट स्टेटमेंट नंबर 3, द रूट लोकस अप्रोचेस स्ट्रेट लाइंस एज असिम्प्टोट एज द लोकस अप्रोचेस टू इनफाइनाइट। बिल्कुल, असिम्प्टोटिक ब्रांच किस तरह से मूव करती है उसके बारे में हम जानते हैं। स्टेटमेंट नंबर 3 भी हमारा सही है, 1 2 3 सही है। हमारा इस पर्टिकुलर क्वेश्चन का आंसर है डी। आई होप यू ऑल हैव परफॉर्म वेल। आपने इन सभी क्वेश्चन को अटेम्प्ट किया होगा, सभी के आंसर सही होंगे। अगले सब्जेक्ट्स के लिए अगले फैकल्टी का इंतजार करिए। थैंक यू सो मच, ऑल द बेस्ट।
चलिए नेक्स्ट हम लोग देखेंगे जरा मैथमेटिक्स के क्वेश्चन को। देखो क्वेश्चन नंबर 61 में एक क्वेश्चन आया हुआ है, इसका जनरल सोल्यूशन पूछ रहा है। देखो अगर इसका हम लोग जनरल सोल्यूशन निकालेंगे तो बेसिकली 3 इक्वेशन दिया है, 5 वेरिएबल है, तो हमें 2 वेरिएबल को एज्यूम करना पड़ेगा, इसमें कोई चॉइस नहीं हमारे पास है। तो मान लो अगर हम लोग x5 को एज्यूम करते हैं, लेट से x5 को मैंने लिया अल्फा, ठीक है, तो यहां से निकाल लो x1 का वैल्यू कितना आ जा रहा है हमारे पास 2 अल्फा, राइट। और यहां से फिर हमने क्या किया, x1 और x5 का वैल्यू रख दिया। देखो x1 माइनस x4 इक्वेशन नंबर 2 देख रहा है, ठीक है, प्लस 2x5 एंड दैट इज इक्वल टू क्या दिया हुआ 0। अब यहां पर x5 का वैल्यू कितना हो गया प्लस 2 अल्फा, राइट, और x1 का वैल्यू कितना है 2 अल्फा माइनस x4 एंड दैट इज इक्वल टू 0। सो x4 का वैल्यू कितना आ जाएगा हमारे पास 4 अल्फा, राइट, x4 आ गया, x1 आ चुका है, x5 आ चुका है। अच्छा फिर से क्या करो यहाँ पर, अब देखो इस इक्वेशन में हमें क्या करता है, चलो ले लेते हैं x3 का वैल्यू बीटा, हमने एज्यूम कर लिया x3 का वैल्यू बीटा। अब अगर x3 का वैल्यू बीटा है तो हम लोग निकाल लेते हैं, हमारे पास x2 निकल जाएगा, देखो कैसे 6x1 माइनस x2 माइनस x3 इक्वल टू क्या दिया हुआ है 0, ठीक है। हमें x1 का वैल्यू कितना पता है 2 अल्फा दैट इज 12, कितना हो जाएगा अल्फा, माइनस x2 निकालना है माइनस x3 का वैल्यू कितना है यार, इट इज बीटा एंड दैट इज इक्वल टू 0। सो x2 का वैल्यू कितना आ जा रहा है हमारे पास, देख लो x2 का वैल्यू इधर हो गया कितना 12 अल्फा माइनस बीटा, ये हो गया x2 का वैल्यू। अब अगर x2 का वैल्यू ये हो चुका है 12 अल्फा, बेसिकली इट इज प्लस है, ये प्लस है, ये प्लस है, तो ये प्लस आ गया, राइट। अब देखो सोल्यूशन लिखेंगे x1 x2 x3 x4 x5, राइट। तो x1 x2 x3 4 का वैल्यू रख दो यहाँ पर। x1 का वैल्यू कितना निकाला हमने अल्फा, x1 का वैल्यू 2 अल्फा, राइट। x2 का वैल्यू है इट इज 12 अल्फा प्लस बीटा, राइट। x3 का वैल्यू इट इज बीटा, x4 का वैल्यू x4 हमारे पास 4 अल्फा, और x5 हमारे पास कितना है, x5 का वैल्यू है अल्फा। अब अगर हम लोग इसको स्प्लिट कर देते हैं, देखो यहां से अल्फा कॉमन ले लो, अगर हम अल्फा कॉमन लेंगे तो कितना आ जाएगा ये, इट इज 2 12 0 4 एंड 1 प्लस बीटा यहां कितना जा रहा है प्लस 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 बीटा, और बीटा अगर हम लोग कॉमन लेते तो देखो क्या आ जाएगा यहां पर, इट इज 0 1 1 0 0। सो हमारे पास देखो सोल्यूशन जो है ये आ रहा है, लेकिन अनफॉर्चुनेटली इसमें कोई भी ऑप्शन मैच नहीं कर रहा है। सो अकॉर्डिंग टू मी द आंसर इज बेसिकली ये, तो मेरे ख्याल से इसका कोई भी ऑप्शन मैच नहीं कर रहा है यार, ठीक है। इनमें से जो भी ऑप्शन हमारे पास गिवन है इनमें से कोई भी ऑप्शन आपका मैच नहीं कर रहा है। सो अकॉर्डिंग टू मी द ऑप्शन आंसर शुड बी दिस, ओके। नेक्स्ट क्वेश्चन इज वेरी सिंपल यार, इसमें क्या दिया हुआ हमसे m का वैल्यू पूछ रहा है। अगर हम इसका डिटर्मिनेंट चेक करते हैं, डिटर्मिनेंट कितना हो जाएगा, इट इज -30 प्लस 2m एंड दैट इज इक्वल टू कितना हो जाएगा यार, आइगन वैल्यू का मल्टीप्लिकेशन कितना हो जाएगा -12। सो यहां से आ जा रहा है 2m इक्वल टू 18, सो m इक्वल टू कितना आ जाएगा 9, दिस इज द आंसर बेसिकली। सो हमारे पास आंसर कौन सा करेक्ट है यार, बेसिकली ऑप्शन डी इज करेक्ट। नेक्स्ट क्वेश्चन इज वेरी सिंपल क्वेश्चन यार। देखो अगर मैं यहां से निकालता हूं, हमसे पूछा है डेल स्क्वायर जेड बाई डेल टी स्क्वायर, राइट। अगर मैं इसका डेल स्क्वायर जेड बाई डेल टी स्क्वायर निकालता हूं, मतलब 2 बार इसको पार्शियली डिफरेंशिएट कर दो, तो इसको एक बार डिफरेंशिएट करें क्या आएगा c, यहां आएगा -c, फिर एक बार डिफरेंशिएट करो क्या आ जाएगा c स्क्वायर, और माइनस माइनस क्या हो जाएगा प्लस। सो बेसिकली c स्क्वायर कॉमन आएगा और यहां क्या आ जाएगा f डैश x प्लस सी टी f डबल डैश, राइट, और क्या आ जाएगा फाई डबल डैश, और क्या आ जाएगा यहां पर फाई डबल डैश कितना आ जाएगा यहां पर, इट इज x माइनस सी टी, राइट। अच्छा अगर यहीं से इसको पार्शियली डिफरेंशिएट कर दो डेल स्क्वायर जेड बाई डेल एक्स स्क्वायर के टर्म में, तो अगर एक्स के टर्म में डिफरेंशिएट करेंगे तो क्या आ जाएगा यहाँ पे डायरेक्टली, इट इज f डबल डैश x प्लस सी टी प्लस फाई डबल डैश x माइनस सी टी। अब अगर हम कंपेयर कर दे देखो, तो ये जो पूरा वैल्यू है ये उठा के यहाँ पुट कर दो, ये वैल्यू कितना है डेल स्क्वायर जेड बाई डेल एक्स स्क्वायर। सो हमारे पास आ जाएगा डेल स्क्वायर जेड बाई डेल टी स्क्वायर एंड दैट इज इक्वल टू सी स्क्वायर डेल स्क्वायर जेड बाई डेल एक्स स्क्वायर, और यही हमारे पास आंसर है। सो बेसिकली इसका आंसर क्या हो जाएगा, इट इज सी स्क्वायर डेल स्क्वायर जेड बाई डेल एक्स स्क्वायर। सो ऑप्शन ए इज करेक्ट, सॉरी एक सेकेंड, ऑप्शन है हमारे पास सी स्क्वायर, सॉरी ऑप्शन बी इज करेक्ट, इट इज सी स्क्वायर डेल स्क्वायर जेड बाई डेल एक्स स्क्वायर। नेक्स्ट क्वेश्चन इज वेरी गुड क्वेश्चन। देखो बेसिकली क्या पूछा है, द वॉल्यूम हमसे पूछा हुआ है। अगर हम लोग वॉल्यूम की बात करते हैं इसमें, देखो वॉल्यूम को क्या लिखेंगे यार हम लोग, इट इज dz dy dx, राइट। हमें मेन चाहिए इसका लिमिट क्या होगा। अब अगर हम इसका लिमिट निकालते हैं तो देखो हमें पैराबोलॉइड दिया हुआ है, एक दिया हुआ है z इक्वल टू 5x स्क्वायर प्लस 5y स्क्वायर, एक हमें दिया हुआ है कितना z इक्वल टू 6 माइनस 7x स्क्वायर माइनस वाई स्क्वायर। अगर इन दोनों को कंपेयर कर दो, यहाँ जरा इसका सॉल्व करते हैं तो देखो कितना हो जाएगा, इट इज 5x स्क्वायर प्लस 5y स्क्वायर इक्वल टू 6 माइनस 7x स्क्वायर माइनस वाई स्क्वायर। सिंप्लीफाई कर लो, इट इज 12x स्क्वायर प्लस 6y स्क्वायर एंड दैट इज इक्वल टू 6 विच इज 2x स्क्वायर प्लस वाई स्क्वायर एंड दैट इज इक्वल टू 1। सो इसको लिख सकते हैं हम लोग x स्क्वायर डिवाइड बाई 1 बाई रूट 2 का होल स्क्वायर प्लस वाई स्क्वायर डिवाइड बाई 1 का स्क्वायर इज इक्वल टू 1। अब देखो जरा सा, ये जो इक्वेशन है किसका हो चुका है यार, ये बेसिकली इलिप्स है। अब ये हमारे पास इलिप्स है। अब अगर हम लोग बात करते हैं इस इंटीग्रेशन का, अगर इस इंटीग्रेशन का लिमिट लगाओगे तो देखो लिमिट क्या आएगा, लिमिट क्या आएगा यहाँ से। अगर हम लोग इसका लिमिट लगाते हैं तो देखो यहाँ बेसिकली हमारे पास z का वैल्यू कितना है, इट इज 5x स्क्वायर प्लस 5y स्क्वायर। यहाँ z का वैल्यू कितना लिमिट लगा देंगे, इट इज 6 माइनस 7x स्क्वायर माइनस वाई स्क्वायर। फिर हम लोग क्या करेंगे, y का लिमिट लगाएंगे और y का लिमिट हम लोग निकाल सकते हैं यहाँ से। y का लिमिट कितना है, देखो y इक्वल टू कितना हो जाएगा, इट इज अंडर रूट ऑफ माइनस साइन 1 माइनस 2x स्क्वायर। यहाँ हो जाएगा y इक्वल टू 1 माइनस 2x स्क्वायर का अंडर रूट। फिर हमारे पास x का वैल्यू कहाँ से कहाँ तक वेरी करेगा यार, इट इज माइनस 1 बाई रूट 2 से लेके 1 बाई रूट 2। लेकिन क्या है, इसका इंटीग्रेशन थोड़ा डिफिकल्ट हो जाएगा, तो हम लोग क्या करते हैं, लगाते हैं जैकोबियन फॉर ट्रांसफॉर्मेशन। थोड़ा सा लगाते हैं हम लोग जैकोबियन ऑफ ट्रांसफॉर्मेशन। अगर हम लोग जैकोबियन लगाते हैं, जरा सा ध्यान से देखो, तो इस जैकोबियन का कन्वर्जन कैसे करेंगे, उसके लिए हम लोग क्या लेते हैं, x इक्वल टू हम लोग क्या लेंगे, इट इज r बाई रूट 2 कॉस थीटा एंड y इज इक्वल टू हम लेते हैं r साइन थीटा एंड z को हम ले लेते हैं z, राइट। सो अगर इसका जैकोबियन निकालेंगे क्या आएगा, x y z डी आर विद रेस्पेक्ट टू r थीटा एंड z। तो हम लोग लिखेंगे क्या, इसका डिटर्मिनेंट का वैल्यू क्या आ जाएगा, इट इज डेल एक्स बाई, मतलब x का पार्शियल डेरिवेटिव विद रेस्पेक्ट टू r, x का पार्शियल डेरिवेटिव विद रेस्पेक्ट टू थीटा एंड विद रेस्पेक्ट टू z, y विद रेस्पेक्ट टू r विद रेस्पेक्ट टू थीटा एंड विद रेस्पेक्ट टू z, z r z थीटा एंड z z। जब इसका आप पार्शियल डेरिवेटिव करके आप इसका जैकोबियन निकालोगे तो जो हमारे पास जैकोबियन का फाइनल वैल्यू आया है, और वो है हमारे पास वैल्यू, बेसिकली हमारे पास जैकोबियन का वैल्यू है, हमने जो निकाला है जैकोबियन का वैल्यू, देखो इट इज r बाई रूट 2। सो ये हमारे पास फाइनल जैकोबियन का वैल्यू आया है। अब हम लोग इसको कन्वर्ट कर देते हैं, तो जब हम लोग कन्वर्ट करेंगे, देखो तो जैकोबियन में जब कन्वर्ट करोगे तो क्या लिखा जाएगा यहाँ पर, r का वैल्यू इट इज r बाई रूट 2। अब यहाँ आ जाएगा dz dr d थीटा। अब लगा दो लिमिट। अब हम लोग क्या करते हैं, पूरे लिमिट को कन्वर्ट कर देते हैं किसमें, r थीटा और z में। तो यहाँ पे लिमिट कितना हो जाएगा, देखो यहाँ पे लिमिट कितना हो जाएगा, देखो यहाँ हो जाएगा इट इज 5 टाइम्स x का स्क्वायर का बेसिकली कितना वैल्यू हो जाएगा, देखो इट इज 5x स्क्वायर। अगर हम लिमिट लगाते हैं तो आ जाएगा हमारे पास 5/2 r स्क्वायर cos स्क्वायर थीटा प्लस 5 r स्क्वायर साइन स्क्वायर थीटा, राइट। और यहाँ आ जाएगा हमारे पास कितना, इट इज 6 माइनस 7/2 बेसिकली 7/2 r स्क्वायर cos स्क्वायर थीटा माइनस r स्क्वायर साइन स्क्वायर थीटा, फाइन। और देखो रेडियस कहां से कहां तक वेरी करेगा, बेसिकली 0 से लेके 1, और हमारे पास थीटा कहां से वेरी करेगा, 0 से लेके 2 पाई, राइट। अब इसको सॉल्व कर लो। सबसे पहले dz को सॉल्व करोगे तो सब्ट्रैक्ट कर दो जरा इन दोनों को, केवल 1 आएगा, तो यहाँ कितना हो जाएगा, देखो अब यहाँ से 1/√2 को बाहर निकाल दो, हमारे पास 1/√2 बाहर आ गया, ठीक है। 0 से लेके 2 पाई बचेगा, राइट, 0 से लेके 1। देखो ये कितना होगा, सब्ट्रैक्ट करो तो इट इज 6, और क्या बचेगा यहाँ पर, माइनस 6 r स्क्वायर, और यहाँ क्या बचेगा, r d थीटा, राइट। अब इसको जरा सा लिख दो, 1/√2 ये कितना हो जाएगा, 0 से लेके 2 पाई, 0 से लेके 1, ये हो जाएगा 6r, कितना हो जाएगा ये 6r माइनस 6r क्यूब, राइट, d थीटा। अब जरा इंटीग्रेट कर दो इसको। अगर इसको इंटीग्रेट करो कितना आ जाएगा, 6r स्क्वायर बाई 2 माइनस 6r टू द पावर 4/4। लिमिट लगा दो r का 0 से लेके 1, और यहाँ पे थीटा का कितना हो जाएगा 2 पाई, राइट, और ये बाहर कितना है 1/√2। ये इसका क्या हो जाएगा आंसर, देखो कितना हो जाएगा ये 1/√2 इंटू 2 पाई, और ये कितना हो जाएगा 6/2 माइनस 3/2, इट इज 3/2, ठीक है। 2 से 2 कैंसिल होगा, कितना आ गया है 3 पाई बाई रूट 2 इज द आंसर। और चेक करो The option is 3 pi by root 2, which is option B is correct. Okay. So let's go with the next question, and the next question will be discussed by our colleagues. Sir, proceed for the next question.
Hello students, I am Srikar Gupta. So I am going to do the next mathematics questions. So from 65. So here this question. See dear students, this is a purely conventional question. There is no shortcut for this. So you have to do the entire conventional process, and entire conventional process here. See the Fourier series representation of this function here. So the length of this interval here, the length of this interval is so 2 pi. So that is 2L is equal to 2 pi, then L is equal to pi here. L is equal to pi. So you need to find out the Fourier series for this. So we all know that the Fourier series is given by A naught, A n, B n, right? So let me take direct, that is what is A naught? A naught is equal to 1 by L integral here 0 to generally alpha to alpha plus 2L f of x dx, we say that. In generally formula is this. So this is becomes here 1 by pi. So integral 0 to 2 pi, here we have to integrate. So 0 to 2 pi f of x is, that is x and pi. So as it is a piecewise function, so let's split this integration from pi to 2 pi here, and this is x dx and this is pi dx. And if you do this one, so you are going to get it is of 3 pi by 2. The integration of this, you will be getting it as 3 pi by 2 here, right? So the next one you have to find that an. So that is 1 by L alpha to alpha plus 2L and f of x into cos of n pi x by L dx here. If you put it L is equal to pi in this, and again here we have to integrate, that it is 1 by pi of, the integration is from 0 to pi, okay? The integration is from 0 to pi and pi to 2 pi here, but 0 to pi it is of x cos, right? X cos L is equal to pi, it gets cancels. So cos nx dx here, and this is pi cos nx dx here. So again it is an integral of uv here. It's an integration of uv. So if you do, after doing this integration, so you are going to get the an value as minus 2 by pi, that is of minus 1 whole to the power of n plus 1 minus 1, okay? So minus 1 whole power n minus 1, minus 1 whole power n minus 1, minus 1 whole power n, right, n, and then minus 1 by n square, you are going to get it, n square. But when it is this type of term you get, na, so it is conditional that, so if n is even, so this becomes 0, if n is odd, it becomes, so some non-zero number. So therefore I write here an is equal to, it is minus 2 by, okay, n pi, see, this is defined for only odd numbers. So I'll take it as pi 2n minus 1 whole square, 2n minus 1 whole square here, right? So for odd it is minus minus, so you are going to get it is this one, so minus 2 by pi. For n is equal to odd it is, so it becomes 1 minus 1, so minus you are going to get, so this is plus 2 by pi, so this becomes minus 2n by pi, right? So this is the n value you will be getting, and similarly you have to find out the bn, that is of 1 by L. Here directly I can write L value, so that is pi, right? So it is an integration 0 to pi, then plus pi to 2 pi. Here it is of x sin n pi x, sin nx dx, and this is pi cos nx dx here, right? Nx dx here. So if you do this integration, so you are going to get the bn is equal to, here it is of minus 1 by n, minus 1 by n you get it, minus 1 by n you get it. So substituting this a naught, a n, b n, so in the Fourier series, so you will be getting the option A. So option A will be the correct answer here. So here this one, see that cos of 2n minus 1 into x by 2n minus 1. So for odd it is present, na? So minus 2 by pi. You are getting the same thing, na? So it is this, the 3 pi by 4, and it is minus 1 by n. See that, minus 1 by n. So option A is the correct answer for this question. It is a lengthy question, absolutely we have to accept it. So the next question is of complex here. So very regular, compulsory question, we all know that we get from complex. So this is one question is given, and whatever the function f of z is given here, this is e power 1 by z, right? So it is not defined at z is equal to 0. It is not defined at z is equal to 0. So therefore this is the isolated singularity for this function here, for this function. So if you want to find out this integral, so there must be one condition, that the pole must lie inside the contour to apply the Cauchy residue theorem. He has given very clearly that the gamma is a closed path enclosing the origin, that means z is equal to 0 is lies inside. So therefore we need to apply the CRT by Cauchy residue theorem. The integral C e power 1 by z dz is given by 2 pi I into the residue at 0. But we all know that, my dear students, so the residue at a isolated singularity is given by the coefficient of z minus a whole power minus 1 in the Lorentz series expansion of e power 1 by z. So we all know that the expansion of e power 1 by z is 1 plus 1 by z plus 1 by 2 z square, right? So this and so on go on. So this is having negative power, so it is a Lorentz series. So therefore here the residue at 0 is given by b minus 1, which is the coefficient of z power minus 1. Yes, what is the quotient of z power minus 1 is 1. So this is the residue. So if I put it here, the answer is 2 pi I. So therefore option B is the right answer for this case. Option B is the right answer for this case. Okay. So it's a previous gate examination question as well. So those who have practiced, so they can do it very clearly, right? Okay. Now let's move on to the 67 question. So here f of z is given and the z value is given, and he is asking what is the value of f of z, right? So put z is equal to 1 by 2 plus 4 iota. So then it becomes 2 iota into 1 by 2 plus 4 iota, and then 6z bar. So that means 1 by 2 minus 4 iota. So if you simplify this, you are going to get, it is that minus 5 minus 23i. So that is option C. If you simplify this, you are going to get the option C here, right? So this is also a simple question here, right? Okay. Moving on to the next one. What is the root of this equation? Dear students, I have clearly say that this question is having the here this particular equation is having the sin x and cos x, where you have to find out the sin and cos values in radians. So that for that we need to have the calculator, but as the calculator is not provided, so therefore it is not that easy to solve or by doing some other procedures. But if you want to get this accurate answer, which are very narrow, okay, which are very narrow here, so therefore it is difficult to identify the solution. Only you can do it by Newton-Raphson method or something like that. For that we need the calculator, because we need to find it in radians. So then if you use the Newton-Raphson method, by Newton-Raphson method, x1 is given by x naught minus f of x naught by f dash of x naught here, x naught. So like that, if you put it the values here, acha, what is x naught to be taken here, because he has not mentioned x naught. As we see that from the options, it is very clearly seen that 2.7 can be taken as a initial approximation, because it is closer to all these points. So therefore if you take the 2.7 minus and here 2.7 into here sine of 2.7 and plus cos of 2.7 here, by the differentiation of this you have to take it. So x cos x, right, it is minus sin x. So x cos x means here 2.7 cos of 2.7 and then plus sin x and then minus sin x. So these two will get cancels. These two will get cancels. So only this much. So this value, so you are going to get something 2.8. So you are going to get the value which is, you know, ultimately I am sure I can say that this has to be calculated by the calculator only. It's not that easy to calculate by hand. Okay. So this one, then again if you use the x2 formula, so x1 minus f of x1 by f dash of x1 if you take it, so then you are going to get this answer as 2.7984. So which is the option D here, right? So obviously this is, you know, I think you can't do this in this examination because of not having the calculator. So the remaining questions will be taken by my colleague. So I am handing over to him. Thank you.
Thank you, Srikhar sir. Thank you so much. Beta, next question is this one. Next question, this is the question based on differential equation, partial differential equation. Here the differential equation is like that: P of small p plus Q of small q equals to R. Such type, where small p is del z over del x and small q is del z over del y. It means here z is a dependent variable and x and y are independent variables. Such type of differential equations can be solved by using Lagrange's multiplier method, for which we have to construct Lagrange's auxiliary equations. Lagrange's auxiliary equations are given as dx upon p equals to dy upon q equals to dz upon r. What is pqr? Beta, p is, after comparison, p is y plus xz. So dx upon y plus xz equals to dy upon equals to dz upon, what is q? Q is with minus sign, minus x minus yz, minus x minus yz, and q is x square minus y square. But बेटा अब देखो यहाँ पर हमें चेक क्या करना है, वी विल ट्राई टू सॉल्व दिस क्वेश्चन बाय यूजिंग Lagrange's multiplier method. So what are the multipliers? If we take y dx plus x dy minus dz, means y, x and minus 1 as the multipliers, then by using componendo dividendo theorem, same operation have to be applied in the denominator also. So by using same operation in the denominator, you will get it as 0. This is the beauty of using Lagrange's multiplier method. Similarly, if we take the multipliers as x, y and minus z, so you will put x dy plus x dx plus y dy minus z dz, x, y and minus z. These are the multipliers. So again we will get 0 is in the denominator. So the multipliers for this differential equation will be y, x and minus 1. By using same operation in the denominator, it will be 0. And again the another set of multipliers will be x, y and minus z. Again you will get 0. If we take first and fourth, if we are taking first and fourth, we will be like this: x dy, बेटा ये होगा y नहीं dy, x dy, so x dy minus dz equals to 0, and using first and fifth one 0 cross multiply से 0 आएगा, तो x dx plus y dy or minus z dz equals to 0. Now try to solve these two differential equations. बेटा यहाँ देखो d of xy minus dz equals to 0, यहाँ तो कोई प्रॉब्लम ही नहीं है. इंटीग्रेशन x dx plus y dy minus z dz or integration of 0. Similarly here we integration and integration. What about the integration? xy minus of z, xy minus of z c1, and the second integration will be like this: x square plus y square minus z square equals to c2. So the most general solution is c1 comma c2 equals to 0. This is the procedure of finding solution using Lagrange's multiplier method. Or what is c1? C1 is this one: xy minus z comma c2 is this one: x square plus y square minus z square equals to 0. Now which one is the right answer? I think the right answer is xz plus y. Yes, xz plus y. So the right answer of this question is option number A. I think option number A is the right answer. X square plus y square minus z square xy plus z. Yes, option A is the right answer of this question. ये भी लेंदी क्वेश्चन था. अब की बार इन्होंने लेंदी क्वेश्चंस पूछे हैं जिनमें से एक ये भी था. Okay, moving on to the next one. सपोज द रैंडम वेरिएबल, अच्छा डिस्ट्रीब्यूशन फंक्शन दिया बेटा, दिस क्वेश्चन इज बेस्ड ऑन प्रोबेबिलिटी और डिस्ट्रीब्यूशन फंक्शन गिवन है, मींस CDF इज गिवन, CDF क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन इज गिवन, दे आर आस्किंग व्हाट इज द प्रोबेबिलिटी दैट x एक्सीड्स 1, प्रोबेबिलिटी इसकी पूछ रहे हैं x एक्सीड्स 1, तो ऐसे लिख सकते हैं 1 माइनस प्रोबेबिलिटी ऑफ x इज लेस देन इक्वल्स टू 1, और वी कैन राइट इट एज x वेरीज फ्रॉम माइनस इन्फिनिटी टू 1, ऐसा लिखा जा सकता है, बट विद इन द लिमिट माइनस इन्फिनिटी टू 0 CDF इक्वल्स टू 0, सो वी कैन कन्वर्ट इट एज 0 लेस देन x लेस देन इक्वल्स टू 1। अब देखिए 0 से 1 तक का इंटीग्रेशन 0 to 1 fx dx 1 माइनस, दिस इज द क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन टिल पॉइंट 1, क्या होता था माइनस इन्फिनिटी से 1 तक की प्रोबेबिलिटीज का सम इज नोन एज CDF, सो इट इज गिवन इन द क्वेश्चन एज f of 1, व्हाट इज f of 1, पुट x equals to 1 in this expression, you will get f of 1, and after solving this 1 minus e to the power minus 1, your answer will be 1 upon e, it means option B is the right answer of this question, question number 70, answer is option number B। Moving on to the next one, टोटल ऑफ 28% ऑफ अमेरिकन मेल्स स्मोक सिगरेट्स, अच्छा वेन डायग्राम का क्वेश्चन है, सिगरेट पीने वाले कितने हैं, सिगरेट्स, और फिर देख रहे हैं सिगार पीने वाले कितने हैं 7%, 28% है सिगरेट, 7% है सिगार, एंड 5% स्मोक्स बोथ सिगार एंड सिगरेट। बेटा फर्स्ट यू हैव टू फिल द इंटरसेक्शन पोर्शन, इट इज 5, सो इट विल बी 2, 7% में से 5%, 2%, 7%, और ये है 23%, एडिंग दीज टू यू विल गेट 30%, इट मीन्स रिमेनिंग विल बी 70%, सो द आंसर ऑफ दिस क्वेश्चन इज 70%, ऑप्शन नंबर डी। क्या पूछ रहे हैं, स्मोक नीदर सिगार नॉर सिगरेट, दिस एरिया इज नोन as A bar intersection B bar means neither A nor B, so the answer of this one is 70%। ये मोस्ट सिंपलेस्ट क्वेश्चन था आपके क्वेश्चन पेपर का, तो किया होगा सबने। मूविंग ऑन टू द लास्ट क्वेश्चन, if the average number of claims handled daily by an insurance company is 5, अच्छा what proportion of days, देखो बेटा proportion पूछ रहे हैं, proportion में base should be of 1 unit और probability में भी base 1 unit होता है, it means they are asking the probability of days having less than 3 claims, assume that the number of claims so and so, चलो ठीक है, random variable will be assumed as number of claims per day as it is given in the question, number of claims per day, let us assume this is the random variable। अच्छा क्या इसका average number of claim पता है, yes पता है, 5 claims per day, 5 claims per day, whenever we are not sure about n but we can find its average value lambda, we will follow Poisson distribution, here lambda is given, so by using the Poisson distribution in this question, क्या पूछ रहे थे, number of claims less than 3 claims, तो less than 3 means less than equals to 2 claim। बेटा Poisson distribution आपको लगाना होगा 0 के लिए, प्लस x equals to 1 के लिए, और प्लस x equals to 2 के लिए। what is the standard formula of Poisson distribution, probability of x equals to r success e to the power minus lambda, lambda power r अपॉन फैक्टोरियल r, ये है। तो यहाँ पर आंसर देखो e टू दी पावर माइनस लेमडा, लेमडा पावर 0, 1 अपॉन फैक्टोरियल 1, लेमडा पावर 2 अपॉन फैक्टोरियल 2, जब आप इसको सॉल्व करोगे इस पूरे को आ जाएगा 37 अपॉन 2 e टू दी पावर 5, 37 अपॉन 2 e टू दी पावर 5, यस यही है, इसका मतलब ऑप्शन है। देखो जिस बच्चे का आंसर था उसने गलत निकाला है, 37 अपॉन 2 e टू दी पावर माइनस 5 इसका आंसर आना चाहिए, डिनोमिनेटर में e की पावर 5 है, ऑप्शन ए इज द राइट आंसर ऑफ दिस क्वेश्चन। This is all about the mathematics portion. Now another faculty will come and will discuss the further questions. Thank you so much.
So let us solve questions of signal and system. Me and along with me Naveen sir, we are going to solve questions of signal. So this is the question 133. Question कुछ ऐसा है, how many number of multiplications is needed in the calculation of FFT with 64 point sequence. अच्छा, तो 64 point FFT अगर कैलकुलेट करना है तो नंबर ऑफ मल्टीप्लिकेशंस की रिक्वायरमेंट कितनी है. So number of multiplications. Now what is the formula for number of multiplication in case of FFT? N by 2 log n with base 2. और यहाँ n की वैल्यू कितनी है 64. So value of n is 64. So 64 by 2 log 64 with base 2. 64 by 2 is 32 and log 64 with base 2 it is how much? It is 2 की power. It is like this. We can write in this way log 2 with 2 की power 6. तो ये किसके इक्वल होगा? ये इक्वल होगा 32 इंटू 6 के. तो आंसर कितना आया 192. और अगर आंसर 192 है तो कौन सा ऑप्शन आंसर है सी. नाउ लेट अस सॉल्व नेक्स्ट क्वेश्चन. सो नेक्स्ट क्वेश्चन इज 134. Which one of the following is the correct Butterworth polynomial for the second order filter? अब एक स्टैंडर्ड रिजल्ट है जो आपको याद रखना है और वो स्टैंडर्ड रिजल्ट यहाँ ऑप्शन बी में लिखा गया है. तो बटरवर्थ फिल्टर है और स्टैंडर्ड सेकेंड ऑर्डर पॉलिनोमियल याद रखना है. तो स्टैंडर्ड सेकेंड ऑर्डर पॉलिनोमियल क्या है एस स्क्वायर प्लस अंडर रूट 2 एस प्लस 1. सो आंसर इज ऑप्शन बी. सो let us solve question number 3. Which one of the following is the correct relation of mapping from the S plane to the Z plane in bilinear transformation? देखो bilinear transformation में जब आप एनालॉग टू डिजिटल फिल्टर कन्वर्जन करते हैं तब जो रिलेशनशिप वेरिएबल्स S और Z में होता है वो इस रिलेशनशिप से दिया जाता है S इक्वल टू 2/2 1 माइनस Z इनवर्स अपॉन 1 प्लस Z इनवर्स. ठीक है, तो इसके लिए आंसर कौन सा ऑप्शन है ऑप्शन डी. अब कुछ क्वेश्चंस नवीन सर एक्सप्लेन करेंगे और उसके बाद एंड में मैं वापस से आऊँगा.
थैंक यू रोहित सर.
म्यूट पे हो सर आप.
So if you see the question, y of t is equal to x of sin t. So next question, 140. The Fourier series representations are based on using constant coefficients, cosine functions, sine functions only, or orthogonal functions. We know that this one is the orthogonal function, which is orthogonal functions we are having. So option D is the correct answer we have. Okay. So remaining questions will deal with the Rohit sir.
So so let us solve next question. So next question is 141. Question rectangular waveform से related है. तो इसके लिए क्या लिखना है, फूरियर ट्रांसफॉर्म. इसका एक डायरेक्ट शॉर्टकट है. व्हाट इज डायरेक्ट शॉर्टकट? राइट डाउन द एरिया. व्हाट इज द एरिया? के इंटू 2t नॉट. सो 2k t नॉट इंटू सैम्पलिंग ओमेगा इंटू राइट मोस्ट एक्सटेंशन ऑफ द इवन सिमेट्रिकल रेक्टेंगल. तो ये इवन सिमेट्रिकल रेक्टेंगल है, इसका राइट मोस्ट एक्सटेंशन कितना है? t नॉट. सो सैम्पलिंग ओमेगा t नॉट. और अगर सैम्पलिंग को सिंक में कन्वर्ट करना है तो जो भी सैम्पलिंग के इनसाइड है इसे आप पाई से डिवाइड कर लो. तो आप लिखोगे सिंक ओमेगा टी नॉट अपॉन पाई. अब आप ऑप्शन चेक करो तो 2k टी नॉट सिंक ओमेगा टी नॉट अपॉन पाई. तो कौन सा ऑप्शन मैच हो रहा है? ऑप्शन ए. नेक्स्ट क्वेश्चन है 142. फूरियर ट्रांसफॉर्म कैलकुलेट करना है t इंटू e की पावर मॉडुलस ऑफ t का. अब देखो एक स्टैंडर्ड रिजल्ट है फॉर e की पावर माइनस मॉडुलस ऑफ t फूरियर ट्रांसफॉर्म इज 2 अपॉन 1 प्लस ओमेगा स्क्वायर. नाउ सपोज दिस इज फंक्शन x ऑफ t. सो दिस फंक्शन विल बी x ऑफ ओमेगा. अब अगर आप t को xt को t से मल्टीप्लाई करो तो ये गिवन फंक्शन f ऑफ t प्रोड्यूस हो जाएगा, बिकॉज एफ टी इज इक्वल टू टी इंटू ई की पावर माइनस मॉड टी. मतलब एक्स टी को कितने से मल्टीप्लाई करना है? t से. सो विच प्रॉपर्टी वी आर गोइंग टू यूज? डिफरेंशिएशन इन फ्रीक्वेंसी डोमेन प्रॉपर्टी. सो एफ ऑफ ओमेगा विल बी इक्वल टू j इंटू डेरिवेटिव ऑफ एक्स ऑफ ओमेगा j इंटू. इसे जब आप डिफरेंशिएट करोगे, टू कांस्टेंट टर्म है, ये एज इट इज़ होगा. 1 अपॉन 1 प्लस ओमेगा स्क्वायर का डेरिवेटिव माइनस 1 अपॉन 1 प्लस ओमेगा स्क्वायर होल स्क्वायर इंटू 2 ओमेगा, इस फॉर्म में. तो आंसर कितना आया? माइनस माइनस, इस माइनस की वजह से माइनस j 2 इंटू 2 4 माइनस j 4 ओमेगा अपॉन 1 प्लस ओमेगा स्क्वायर होल स्क्वायर. अब अगर आप ऑप्शंस मैच करें तो कौन सा ऑप्शन मैच होगा? ऑप्शन बी, माइनस 4j ओमेगा अपॉन 1 प्लस ओमेगा स्क्वायर होल स्क्वायर. ठीक है. नेक्स्ट क्वेश्चन नंबर 143. ये थोड़ा ट्रिकी क्वेश्चन है. सबसे पहले इसमें एक सिग्नल x ऑफ t है. x ऑफ t से रिलेटेड कुछ इन्फॉर्मेशंस है और हमें फंक्शन xt फाइंड आउट करना है. फर्स्ट इन्फॉर्मेशन इज टाइम पीरियड इज 4. t नॉट अगर 4 है तो ओमेगा नॉट कैलकुलेट करो 2 पाई अपॉन टी नॉट से. तो 2 पाई अपॉन 4, तो ओमेगा नॉट कितना? पाई बाई 2. ठीक है, फर्स्ट इन्फॉर्मेशन यूज़ हो गया. अच्छा, अब इसके बाद हम लोग डायरेक्टली फोर्थ इन्फॉर्मेशन पर चलते हैं. देयर इज अ सिग्नल yt. फॉर yt एक्सपोनेंशियल कोएफिशिएंट इज dk एंड ck इज द एक्सपोनेंशियल कोएफिशिएंट ऑफ विच सिग्नल? xt. ठीक है, तो xt का कोएफिशिएंट है ck और yt का कोएफिशिएंट है dk. ठीक है. अच्छा, रिलेशनशिप क्या है एक बार इसे भी हम लोग देखते हैं. सो व्हाट इज़ द रिलेशनशिप? ठीक है, तो रिलेशनशिप है e की पावर माइनस जे पाई के, e की पावर माइनस जे पाई बाई 2k इंटू सी के. ठीक है, अगर आप कंपेयर करो तो यहाँ टाइम शिफ्टिंग प्रॉपर्टी यूज़ करना है. इसे आप लिखते e की पावर माइनस जे के ओमेगा नॉट टी नॉट इंटू सी के. ये कुछ इस फॉर्म में लिखा गया है। तो अगर डी के इस फॉर्म में लिखा गया है तो वाई टी एक्स टी से कैसे रिलेटेड होगा, एक्स ऑफ टी माइनस टी नॉट से। तो हमें यहाँ पर क्या कैलकुलेट करना है, टी नॉट। पहले तो टी नॉट कैलकुलेट करो, तो कैसे कैलकुलेट होगा, इन दोनों को कंपेयर करो। तो ओमेगा नॉट टी नॉट ये किसके इक्वल है, पाई बाई 2k। तो यहाँ से टी नॉट आपने कैलकुलेट किया पाई अपॉन 2 ओमेगा नॉट। अच्छा, यहाँ ओमेगा नॉट हमने पहले लिखा है, ये कितना है, पाई बाई 2। अब डिनोमिनेटर में ओमेगा नॉट को पाई बाई 2 लिखोगे तो टी नॉट कितना आएगा, 1। और अगर टी नॉट 1 आ गया तो रिलेशनशिप क्या आया, वाई टी इज इक्वल टू एक्स ऑफ टी माइनस 1। अब हम लोग डायरेक्टली 5 पर भी जाते हैं, फिर 4 पर आएंगे। अच्छा, फिफ्थ इंफॉर्मेशन में देखो, सो दिस LHS इज द पावर ऑफ सिग्नल XT। टाइम डोमेन में पावर कैलकुलेशन का फॉर्मूला है, तो पावर ऑफ XT इट शुड बी हाउ मच, 1/2। तो XT का पावर कितना होना चाहिए, 1/2। अब अगर ऑप्शंस पर आप कंसंट्रेट करो तो कोई साइनोसाइड है ए नॉट कॉस ओमेगा नॉट टी, पावर लिखना है तो आप क्या लिखते हैं, ए नॉट स्क्वायर बाई 2। और यहाँ पर पावर कितना है, 1/2। इट मीन्स पीक एम्पलीट्यूड शुड बी आइदर +1 और -1, ठीक है, क्योंकि साइनोसाइड का पीक एम्पलीट्यूड या तो +1 या फिर -1 होगा। तो +-1 होल स्क्वायर बाई 2 कितना था, 1/2, तो पावर 1/2 आ जाता। इट मीन्स आंसर बी या सी में से कोई एक है। अब बी और सी में से भी कौन सा आंसर होगा, वो कैसे क्लैरिफाई होगा, इस वाले इंफॉर्मेशन से। ये जो रिलेशनशिप हमने अचीव किया है, अच्छा सपोज आंसर इज ऑप्शन बी, हम लोग ये मान लेते हैं कि आंसर ऑप्शन बी है। अगर इसको अज्यूम करके चलते हैं तो इससे हमने क्या अज्यूम कर लिया कि ये एक्स ऑफ टी है। देखो बी या सी में से आंसर है, अगर बी को लेकर के चलोगे ना तो ये वाला रिलेशनशिप सेटिस्फाई होगा, जो कि ये कह रहा है कि वाई टी कैसा सिग्नल है, ऑड, और वाई टी किसके इक्वल है, एक्स ऑफ टी माइनस 1 के। अच्छा, अगर आप इसे अज्यूम कर लो तो कुछ लिखते -1 की पावर m इंटू कॉस ओमेगा नॉट टी, ये तो एक्स टी है ना, और टी को किससे रिप्लेस करो, टी माइनस 1 से। तो बेटा जब आप टी माइनस 1 से रिप्लेस करोगे तो कुछ लिखते -1 की पावर m इंटू कॉस ओमेगा नॉट टी माइनस ओमेगा नॉट, ओमेगा नॉट कितना है, पाई बाई 2। तो अब अगर ध्यान से देखो तो कॉस ओमेगा नॉट टी माइनस पाई बाई 2, मतलब ये साइन में कन्वर्ट हो जाएगा। और जैसे ही ये साइन में कन्वर्ट होगा तो ये जो फंक्शन वाई टी है ये फिर किस टाइप का सिग्नल बन जाएगा, और सिग्नल बन जाएगा। इसका मतलब फोर्थ इंफॉर्मेशन सेटिस्फाई हो रहा है। इसका मतलब कौन सा ऑप्शन आंसर है, ऑप्शन बी। ऑप्शन सी में ये वाला कंडीशन सेटिस्फाई नहीं होगा, क्योंकि उसमें आप एक्स टी को अगर ये फंक्शन अज्यूम कर ले, उसमें फिर टी को टी माइनस 1 से रिप्लेस करें तो वाई टी ऑड नहीं मिलेगा, ठीक है। नेक्स्ट क्वेश्चन इज 144। थोड़ा ये मैथमेटिक्स से रिलेटेड क्वेश्चन भी है, प्लस सिग्नल का भी कॉन्सेप्ट है। अगर आप देखें तो ये जो अल्फ़ा 2 है, व्हाट इज दिस अल्फ़ा 2, सपोज दिस इज वाई, ओके, दिस इज फंक्शन वाई, एंड व्हाट इज अल्फ़ा 1, सपोज दिस इज फंक्शन एक्स। तो एक्स इनपुट है, वाई आउटपुट है, और सिस्टम कैसा है, एक LTI डिस्क्रीट सिस्टम है। अच्छा, अब यहाँ पर थोड़ा कंसंट्रेट करो। सिस्टम के स्टेबल होने के लिए अल्फ़ा 1 और अल्फ़ा 2 पर कंडीशन बताना है कि क्या होगा, ठीक है। एक सिंपल सा लॉजिक, ये जो शेडेड रीजन आप देख रहे हो, इस शेडेड रीजन का इनइक्वालिटी लिखना है। समझ में आए, ये जो शेडेड रीजन है ये सिस्टम के स्टेबल होने का रीजन है, और इस रीजन के लिए हमें क्या लिखना है, मैथमेटिकल इनइक्वालिटी लिखना है। सबसे पहले ये जो लाइन इक्वेशन आपको दिख रहा है, इसे अगर आप लिखें तो ये कुछ y इक्वल टू मॉड एक्स का फॉर्म है। तो इसको मैं सिंपल ऐसा लिख देता हूँ, अगर ये ओरिजिन से पास होता तब आप लिखते मॉड एक्स, तो ये जो डॉटेड लाइन है इसका फंक्शन क्या, मॉड एक्स। इससे आपने 1 से डाउनवर्ड शिफ्ट किया तो मॉड एक्स में आपने कितना सब्ट्रैक्ट किया है, -1। सिंपल है, सिंपल सा लॉजिक। ये जो डॉटेड वी शेप स्ट्रक्चर है ओरिजिन से पास हो रहा है तो इसका इक्वेशन है मॉड एक्स। इसे आपने 1 से डाउनवर्ड शिफ्ट किया तो आप क्या लिखते हैं, मॉड एक्स माइनस 1, ठीक है। अच्छा, अब अगर ये वाला रीजन चाहिए, ये जो शेडेड रीजन यहाँ रिप्रेजेंट हो रहा है, ये जो शेडेड रीजन रिप्रेजेंट हो रहा है, दिस शेडेड रीजन इज अबव दिस लाइन, ओके। तो ये जो फंक्शन है जो सॉलिड पर्पल कलर से मैंने रिप्रेजेंट किया है, इसके अबव ये शेडेड रीजन है। तो आप इनइक्वालिटी ऐसे लिखते, मॉड एक्स माइनस 1 दिस शुड बी लेस देन वाई, ठीक है, क्योंकि ये वाला जो रीजन है इसके ऊपर है। तो आप लिखते y शुड बी ग्रेटर देन मॉड x माइनस 1। अच्छा, x किसके इक्वल है, अल्फ़ा के, सो मॉड अल्फ़ा 1 माइनस 1 शुड बी लेस देन y। अच्छा, y किसके इक्वल है, अल्फ़ा 2 के। तो यहाँ से बेटा इनइक्वालिटी क्या आया, कुछ ऐसा आया, अल्फ़ा 2 अल्फ़ा 1 शुड बी लेस देन 1 प्लस अल्फ़ा 2। एक इनइक्वालिटी तो मिल गया, ठीक है। मॉड अल्फ़ा 1 शुड बी लेस देन 1 प्लस अल्फ़ा 2, मतलब ये भी हो सकता है, ओके। एंड और कोई ऑप्शन तो इसमें वैसे दिख भी नहीं रहा है, तो कौन सा ऑप्शन आंसर है, ऑप्शन बी, क्योंकि और कोई ऑप्शन है ही नहीं। और वैसे भी अगर आप सेकेंड को भी चेक करोगे तो वो करेक्ट है, क्योंकि अल्फ़ा 2 का रेंज, ये जो अल्फ़ा 2 है वाई एक्सिस पर, इसका रेंज -1 to 1 है, इसका मतलब मॉड अल्फ़ा 2 लेस देन 1 है। तो आंसर कौन सा ऑप्शन आया, ऑप्शन बी। अच्छा, अब इसके बाद लास्ट क्वेश्चन, ये स्टेटमेंट वाला क्वेश्चन है, रीज़न असर्शन वाला है, तो इसमें थोड़ा देखना पड़ेगा, ओके। तो स्टेटमेंट 1 है, अ सिस्टम इज LTI इफ एंड ओनली इफ देयर एग्जिट्स अ सिग्नल कॉल्ड द सिस्टम यूनिट इम्पल्स रेस्पॉन्स। मतलब सिस्टम LTI होगा अगर उसमें एक सिग्नल एग्जिस्ट करेगा जिसका नाम क्या होगा, यूनिट इम्पल्स रेस्पॉन्स। दिस स्टेटमेंट इज करेक्ट बिकॉज यूनिट इम्पल्स रेस्पॉन्स इज डिफाइंड ओनली फॉर LTI सिस्टम। व्हाट अबाउट स्टेटमेंट 2, चलो एक बार पढ़ते हैं। द आउटपुट ऑफ ए डिस्क्रीट टाइम LTI सिस्टम इज इक्वल टू द कन्वोल्यूशन सम बिटवीन द इनपुट सिग्नल एंड इट्स यूनिट इम्पल्स रेस्पॉन्स। मतलब सिस्टम का आउटपुट मिलेगा, LTI सिस्टम का आउटपुट मिलेगा किसके कन्वोल्यूशन से, इनपुट और इम्पल्स रेस्पॉन्स के कन्वोल्यूशन से। तो दिस स्टेटमेंट इज ऑल्सो करेक्ट, क्योंकि LTI सिस्टम का आउटपुट हम लोग ऐसे ही कैलकुलेट करते हैं, इनपुट को इम्पल्स रेस्पॉन्स से क्या करते हैं, कन्वर्ट करते हैं। चलो ये दोनों स्टेटमेंट करेक्ट हैं। एंड स्टेटमेंट 2 इज करेक्ट एक्सप्लेनेशन ऑफ स्टेटमेंट 1, क्योंकि स्टेटमेंट 1 कह रहा है कि LTI सिस्टम में ही बस केवल इम्पल्स रेस्पॉन्स डिफाइन होता है, और अगर LTI सिस्टम में ही बस केवल इम्पल्स रेस्पॉन्स डिफाइन हो रहा है तो बिकॉज दिस कंडीशन इज सेटिस्फाइड, ओके। तो स्टेटमेंट 1 भी करेक्ट है, स्टेटमेंट 2 भी करेक्ट है, और स्टेटमेंट 2 स्टेटमेंट 1 का करेक्ट एक्सप्लेनेशन है। तो इस क्वेश्चन के लिए कौन सा ऑप्शन आंसर होगा, ऑप्शन ए, क्योंकि ऑप्शन ए में स्टेटमेंट 1 स्टेटमेंट 2 बोथ आर ट्रू एंड स्टेटमेंट 2 इज करेक्ट एक्सप्लेनेशन ऑफ स्टेटमेंट 1। चलो, सिग्नल सिस्टम के क्वेश्चंस कंप्लीट हो गए। अब कम्युनिकेशन सिस्टम के क्वेश्चंस के आंसर्स आपको एक्सप्लेन किए जाएंगे, बस थोड़ी देर का वेट कर लीजिए आप।
Hi friends, now we will discuss the solutions of measurement subject. So in this measurement total 14 questions are there. So I will discuss some questions and Raju sir will discuss the remaining questions. So in one of the question, just you can observe question number 10, two wattmeters are producing a reading of 1500 watts and 2500 watts. So what is asking this one, what is the per phase reactive power if the voltage, line voltage is 220 volts. For this question, simple one, in case of 2 wattmeter method, we have seen total 3 phase power measured by this 2 wattmeter method is simply, we write down the equation is root 3, sorry, this will give root 3, yeah, this actually will be root 3 of the difference of the powers P1 and P2. So these are 3 phase power. If you take the per phase power, this will give total 3 phase power by 3. So directly you can use this equation, that will give P1 minus P2. This is actually root 3 upon 3. The finally you will get is P1 minus P2 by root 3. So this time I am taking the magnitude, per phase power magnitude only I am taking, ignore about the signs. So this P1 is 1500 and P2 is 2500. So the difference is actually comes, just I am taking this 2500 minus 1500 or 1500 minus 2500, just only take the magnitude, and if you calculate, that value comes is 577.3 watts is the value you will get. So answer for this one, direct question, answer is C is the answer for this one. Okay. Answer is C, simple question, right. Now come to the next question. A 3-phase balanced star connected load motor draws a real power of 5.6 kilowatts from the line voltage of 220 volts and the line current is also is given. Just he is asking about the power factor, what is the approximate power factor. So the power equation simply you can write down is Vi into what, take the value of cos phi. Okay. So in this case, this actually 3-phase balanced star connected motor, real power of 5.6 watts, this is 5.6 into 10 cube, and total 3-phase power, for that we are generally writing this one is root 3, and this value is given by voltage of, from the line voltage of 220 volts, take 220, and the current is of 18.2 and power factor is given by cos phi. Directly you can calculate the cos phi. This value comes is 0.8075 is the value you will get, 0.8075. So this is the answer. So that answer for this one is B is the answer for this. Okay, a simple question. Now coming to the next part, next question. Which one of the following is used to protect the standard cell and galvanometer against overcurrents? Any overcurrents point of protection generally you can use by connecting a resistance is connected in series with the equipment. So that answer for this one is of a series resistance is what connected is what in series with the equipment. Yeah, in the one of the application of potentiometer is of measurement of low resistance. So in that case, he has given the setup is given like this, you can think of. So this is standard resistance, the standard resistance of 0.1 ohm, 0.1 ohm, and is unknown resistance. The voltage is measured across the standard resistance and as well as the unknown resistance. So the voltage across the standard resistance is of 1 volt, voltage across unknown resistance is 0.4 volts. So if you take these, the voltage across this one is 0.4 volts and the voltage across the standard resistance is 1 volt. Okay. These are all done by using a potentiometer is used to measure these two resistances. That means you are using one, initially you are connecting the across the 1 volt and next one you are using a switch that is used to measure the voltage across the 0.4 volts. So what is asking, now the current is flowing to this one, yeah, the current is flowing to this one is of I is the current, then what is the power loss in this resistance he is asking. For this simple one, what you can take, this is the voltage equation for the standard voltage Vs by Vr is simply saying that Is by Ir. So, from this if we calculate this Vs value is 1 volt and Vr voltage is 0.4 and I is the common part and S's value is 0.1 and this is the value of R. From this you can able to calculate the resistance value is 0.04 ohms is the resistance. And if you calculate the current I is calculated which is passing through the same series resistance of R and S, that is through S also it is flowing, but the I value will get is 1 by 0.1, that actually comes is 10 amps is the current. So, what the power loss in the resistance is I square R, that will gives 10 square into this is 0.04. So, finally you will get is 4 watts is the power loss in the resistance you can able to get. So, the answer for this one is C is the answer you will get. So, this is the answer you will get is C is the answer for this question. Simple question, measurement of unknown resistance by using a potentiometer. See the next question. So, in this one potentiometer is usually is the, what is the advantage of using the potentiometer is of one is used for measurement of voltmeter, ammeter and wattmeters, direct calibration of this one you can use, and here it is not used for measurement of current and power, it is used for measurement of low resistance, but is not specifically given, he has given and combination. For this statement is wrong, only first statement is correct, it is used basically for calibration of ammeter, voltmeter and wattmeter purpose. So, answer for this one is A is the answer. Okay. So, remaining questions will be explained by the Raju sir. Okay.
Yeah. Good evening, students. Yeah, this is question number 16. A simple slide wire is used for measurement of current in a circuit. The voltage drop across a standard resistor of 0.1 ohm is balanced at 75 centimeters. Okay. So let S be the standard resistance.
Color.
Let S be the standard resistance. Yeah, how much given? S be the standard resistance of 0.1 ohm is balanced at 75 centimeters. Okay, fine. So corresponding L1 length is 75 centimeters. But in all these problems, always we have to consider, right, standard cell EMF of 1.45 volts is balanced at 50 centimeters. In all potentiometer problems, standard cell EMF taken as reference. So standard cell EMF E. Standard cell EMF 1.45 volts, balance rate, what length? 50 centimeter length. And directly we can do 1.45 volts, 50 centimeter length, right? 75 centimeters, how much? Or otherwise, by using formula, suppose E1 upon E is equal to, E1 is the unknown we want to calculate, right? E1 upon E is equal to L1 upon L. So at 75 centimeter length, what is the voltage drop or what is the unknown EMF I want to calculate? So E by L into L1, right? So E1 equal to 1.45 volts upon 50 centimeters into 75 centimeters. After calculating this one, right, this calculation value around 2.175 volts. This is the unknown EMF. 2.175 volts. This is the unknown EMF, right? But what they given? This is the unknown EMF. This is the voltage drop across a standard resistance of 0.1 ohm, right? So let S be the standard resistance. This is already we know 0.1 ohm, right? This unknown EMF also I know. Fine. Now I want to calculate the current I1. This is the current. So current I1 is equal to, can I write like this? E1 upon S. E1 is how much? 2.175 upon 0.1 ohm. Right? So it's nothing but 21.75 amperes. Right? It's the direct question from the class notes. So hence option A is the correct answer. Okay. Hence option A is the correct answer. Okay, next we can look at the next question. Yeah, this is a direct simple bit only. Which one of the following method is not used in measurement of high resistance? So what are the methods available for measurement of high resistance? It's like direct deflection method, correct? Mega ohm bridge method, Megger method, and Kelvin double bridge. Kelvin double bridge is used to measure low resistance. So what they are asking is not used for measurement of high resistance. Hence option D is the correct answer. Okay. Which one of the following is intended for the rapid measurement of the winding resistance of machines and transformers? So usually the transformer winding resistance is nothing but insulation resistance. Insulation resistance values are very high, in the order of something mega ohms. So obviously which method we are going to use? So Megger is used to measure high resistance. Okay. Direct deflection method is used to measure also high resistance, but Megger is the most commonly used method in industries. So hence option C is the correct answer. So direct deflection.
దాంట్లో వైండింగ్ రెసిస్టెన్స్ అంటే కాపర్ రెసిస్టెన్స్ గురించి అడుగుతున్నాడు, కెల్విన్ డబుల్ గురించి వాడాలి.
Okay. Okay. So just once again, just we can read the question. Rapid measurement of winding resistance. Okay, take care. If it is suppose insulation resistance, if it is suppose asking about insulation resistance is measured by high resistance methods. What are the insulation resistance measured by high resistance methods? Like Megger, direct deflection. But here what they are asking, winding resistance is nothing but internal resistance only. So winding resistance of the machine usually like DC shunt motors, all these are winding resistance are very low. So that is the reason hence we can use Kelvin double bridge is the best method. Okay. So Kelvin double bridge is the best method for measurement of low resistance. Hence option D is the correct answer. Right. A regular Wheatstone bridge is used to measure high resistance. The bridge has ratio arms 10,000 ohms and 10 ohms. What do you mean by ratio arms? So ratio arms means that adjacent arms are called ratio arms. So P and Q. P how much given? 10,000 ohms or 10 kilo ohms. 10,000 means 10 kilo ohms. Q 10 ohms. The adjustable arm has a maximum value of 10,000 ohms. Right? Hence we are taking unknown resistance is R. I want to calculate. Let S be the standard resistance. Assume 10,000 ohms is nothing but 10 kilo ohms. I want to calculate unknown resistance. Okay. What is the maximum resistance that can be measured by this arrangement? So we know this one. Bridge is under balanced condition. Product of opposite arms equal, or otherwise simply P by Q equal to R upon S. I want to calculate unknown resistance. R equal to P by Q into S. So anyway, 10 kilo ohms upon Q10, S is 10 kilo ohms. Right, this 10 cancel. So anyway, 10 mega ohms, kilo into kilo, mega ohms. So hence option, right, B is the correct answer. Fine. Yeah. Next. Yeah, next question. A highly sensitive galvanometer can detect a current as low as 0.1 nanoamperes. Okay, what they given? It's a Wheatstone bridge only. The galvanometer current is 0.1 nanoamperes. So 0.1 into 10 to the power of minus 9 amperes. Okay, what they are taking? Each arm of the bridge has a resistance of 1 kilo ohm. Okay, let R be the resistance of each arm, 1 kilo ohm. Fine. Input voltage applied to the bridge, 20 volts. What they are asking? If the resistance of the galvanometer can be neglected, internal resistance of galvanometer, RG, neglected. Right. What is the smallest change in resistance of the bridge? What is the meaning of this one? This question is nothing but quarter bridge concept. Because all arms of the resistance are R, in one of the arm of the bridge, there is a change of resistance. So directly we can solve. Let us assume each arm resistance is R, but in one of the arm of the bridge, there is a change of resistance occurred, so that can be detected by galvanometer. So galvanometer current already IG mentioned to you. So this is nothing but quarter bridge. You may ask it, why you are considering quarter bridge? In one of the arm only change is occurred. Minimum change we are taking. So according to quarter bridge concept, so output voltage or Thevenin's voltage equal to E by 4 into delta R by R. Right. So anyway, calculate RTH. If I am calculating RTH equal, all resistance are assumed as equal only, R parallel with R, again R parallel with R. I am not drawing the equivalent circuit of RTH directly, just voltage source short it, then R parallel with R, R parallel with R. This is R by 2 plus R by 2, R only. So Thevenin's resistance, you will get 1 kilo ohm, right? If I am redrawing the equivalent circuit, right, RTH, Thevenin's resistance, always in series with VTH. This is across B and D terminals of the bridge. If I am representing, suppose, if I am representing the terminals of the bridge, this is A, B, C and D. Across B and D terminals of the bridge, if I am calculating the galvanometer current, right, galvanometer internal resistance RG0, this is across B and D, VTH, right. So IG equal to, IG or I equal to VTH upon RTH plus RG. RG anyway 0. So VTH is equal to IG into RTH. Okay. IG already given how much? 0 point, right, 0.1 into 10 to the power of minus 9. Okay, fine. Yeah, you can calculate. So VTH is equal to 0.1 into 10 to the power of minus 9. RTH how much? 1 kilo ohm is nothing but 10 to the power of cube. So 0.1 into 10 to the power of minus 6. This is the voltage. So directly you can substitute in this equation. Thevenin's voltage is equal to E by 4 into delta R by R. Okay. So if I am substituting here, Thevenin's voltage 0.1 into 10 to the power of minus 6, right, equal to input supply 20 volts, 20 by 4 into delta R by R. R 1 kilo ohm, nothing but 10 cube. Now you can simplify this work. So then delta R you will get 20 micro ohms. So hence which option is 20 micro ohms? So hence option D is the correct answer. Okay. Yeah. Next. A resistance of approximately 3000 ohms is needed to balance a bridge. It is obtained in a 5-dial resistance box. Okay. So by you are conducting experiment, different types of decade resistance box is given. But finally here what I want to do, the measurement is to be guaranteed, GAE given, guaranteed accuracy of 0.1 percentage. So directly we can do 3000 plus or minus 0.1 percentage of full scale deflection, right? So anyway 0.1 percentage of 3000 I need to take it. So remove the percentage symbol upon 100 into 3000. So 3000 plus or minus, right, 3 ohms. So what is the minimum value? 2997 to 3000, 3 ohms. So hence option A is the correct answer. Okay. Which one of the following method is not used in measurement of low resistance? Right. Which is the low resistance method? Kelvin double bridge is low resistance method. Right. Potentiometer is also low resistance method, less than 1 ohm only. Ammeter voltmeter method is also low resistance method. Right. So all these are low resistance methods. So which is high resistance method? This is direct deflection method is a high resistance method. Hence, so option A is the correct answer. Not used in low resistance. Okay. Yeah. Last question. Consider the following statement. Campbell's bridge measures an unknown mutual inductance in terms of standard mutual inductance. Obviously correct statement. What is the second one? Campbell's bridge is used for measurement of self-inductance in terms of standard mutual inductance. So hence, which is the correct statement?
One. A answer.
So obviously, only statement A is the correct answer. Right? Because this is a direct method. This may not be correct statement. Yeah, last question. What they are giving? Carry-Foster bridge is used for measurement of capacitance in terms of standard mutual inductance. Correct? Measurement of capacitance in terms of is a function of standard mutual inductance. Correct? This statement is correct. Head-Wheeler bridge is used for measurement of mutual inductance in terms of standard mutual inductance. So anyway, statement number 1 is perfectly correct. So hence option A is the correct answer. Okay. So these are all from measurement questions. Okay, all the best.
Okay. Next other subject will continue. Thank you.
Thank you.
So now I will do the questions related to communication systems. Okay. So if you see this question number 121 here, the spectral efficiency of 16 QAM we have to find out. Okay. The spectral efficiency, it also can be called as bandwidth efficiency. If you see the options, okay, the units are bits per second per hertz. So bits per second means this is bit rate, hertz means it is the bandwidth. Okay. So the formula for bandwidth efficiency or spectral efficiency is bit rate by bandwidth. So if you see what is the bandwidth of M array QAM, okay, or M array PSK, the bandwidth of M array QAM and M array PSK will be same. Okay, the QAM is one of the digital modulation scheme. This is the composition of ASK and PSK. The bandwidth of M array QAM and M array PSK will be same, and that is given by RB by log M base 2. This is okay. So the default bandwidth is minimum bandwidth we take. The minimum bandwidth of M array PSK is this. Then the bandwidth efficiency will be equals to. So if you substitute this, the bandwidth here, this is actually the bandwidth. Okay, the bandwidth of this is, okay, M array QAM, this is, okay, and if you substitute here in place of bandwidth, if you substitute this is log M base 2, and it is 16 array QAM, so M is equal to 16, so log 16 base 2, log 16 base 2 will be 4, so 4 bits per second per hertz. So option D is going to be correct. And if you see this question number 122, it is simply finding the minimum sampling rate. The minimum sampling rate, okay, will be 2 FM. Okay, 2 times 2. What is the frequency of this? This is 100. So this will be 200 hertz. Okay, so the option B will be correct for this. And if you see this question number 125, this is related to AM. Okay, so this is the AM power is given 10 kilowatt. Okay, and the modulation percentage is given 60. Okay, so this is then we have to find the carrier power PC, we have to find out. So we know that the AM power PT is equals to PC into 1 plus mu square by 2. PT is given as 10 kilowatt and we have to find PC. The mu is given 0.6, so 0.6 square, so this is 0.36 by 2. This is, and if you see this, then you come to know PC will be equals to 8.47 kilowatt. Okay, so option B will be correct for this. Okay, and if you see this question number 126, the ambiguity is there in the options. Okay, this is about FM. Okay, the FM demodulation by using PLL. Here the KF value is given. Okay, and the deviation, the frequency deviation is given. Okay, and the message signal is the sine wave message signal, and we have to find the RMS output voltage we have to find out. Okay, so what we get at the PLL detector output is we are going to get the message signal. Okay, that sinusoidal message signal we are going to get in the final output. The message signal we recover by using FM demodulator, and for that reconstructed message signal we have to find out the RMS voltage we have to find out. So delta F is given, this is delta F is actually KF AM. Okay, so delta F is given 75 kilowatts and KF is given 100 kilohertz per volt and AM. So from this AM will be equals to 75 by 100, this is 7.5 volts you will get. So this is the peak voltage of the resultant sinusoidal message signal. Then what about RMS voltage? RMS voltage will be the peak voltage by root 2. So this is 7.5 by root 2. So if you do this, it comes to be 5.3 volts. But the options given are not matching here. Okay, so here some ambiguity. Okay, in the given options. Okay, ambiguity is there. Okay, so here the answer what we are getting is 5.3 volts is what we are getting. Okay, yes. Now this is about finding the noise factor. The noise factor is also called as noise figure. Okay, so the noise factor or okay, the noise figure of amplifier, it will be given by SI by NI by S0 by N0. Okay, in the regular classroom I given this formula. The figure of merit is output SNR by input SNR, whereas the noise figure is input SNR by output SNR. Okay, so here this is input signal power, it is SI, and this is NI, this is
okay, signal power and noise power. This is SI here and this is NI. Just substitute, okay, and this is S naught and this is N naught, okay, S naught and N naught. You just substitute the values, then you will come to know this noise factor will be equals to, this is 2.666 you will get. Just substitute the values, this is what you are going to get. So option A is going to be correct. And if you see, this question is related to information theory. Actually speaking, this is it was not there in the syllabus for electrical students, and for electronic students it is very easy question, okay, but for electrical students it is not specially mentioned in the syllabus, information theory, okay. And what is the formula here is the probabilities are given here, okay, and we have to find out the entropy, we have to find out, okay. The source is emitting 5 symbols with these probabilities and we have to find out the entropy of that source. Okay, the probabilities, if you just denote this as P1, this is, and P2, okay, P3, P4, P5, these are the probabilities. Then entropy is given by the formula summation I is equals to 1 to 5, this is Pi log 1 by Pi base 2, this is the formula, okay. So once you know the probabilities of the symbols, you can find the entropy by using this formula, and by substitution this is 1 by 2 log 2 base 2 plus this is 1 by 4 log 4 base 2 plus 1 by 8 log 8 base 2 plus 1 by 16 log 16 base 2 plus 1 by 16 log 1 by 16 base 2. So 2 times you will get, so 1 by 16 log 16 base 2. So base 2 will be there, okay. So from computation it will comes to be 1.875. The units for entropy is bits per symbol, okay. So option B will be correct for this, okay. And this is a straight question, this is related to amplitude modulation, and we have to find out the modulation index mu is equals A max minus A min by A max plus A min, and here this is, I can say E max minus E min by, this is E max plus E min. So E max minus E min is 80, E max plus E min is 220, and if you do this it comes to be 36.4%. So option C will be correct for this. And if you see this question here, okay, so this question is related to, okay, so the noise power contributed by the resistor in the receiver bandwidth. So one formula is there, okay, the noise power N equals to kTB watts, okay. Same thing, this is actually very easy question for electronic students, but unfortunately this is given for electrical students, okay. So this is how you can find okay, the noise power that is contributed by the resistor, okay, for the given receiver. So here K is the Boltzmann's constant, and that is 1.38 into 10 power minus 23, this is joules per Kelvin. This is the Boltzmann's constant, K. So T is the temperature in degree Kelvin, the temperature is given in degree centigrade, and you have to convert to degree Kelvin. So plus 273, if you add to 273 that will be converted to degree Kelvin, this is 303 degree Kelvin, this is, okay. B is given, so what is the bandwidth here is given is 12 kilohertz is given, so this is 12 into 10 power 3. So by substitution, just substitute these values, K value, T value, B value. So from substitution you will come to know this is 5.017 into 10 power minus 17 watts you will get, okay. So here option D is going to be correct. So this is formula based question. And if you see, this is also a formula based question. So here the RMS noise voltage, okay, at the output of an amplifier, one formula is there. So RMS noise voltage Vn is equals to under root of 4 kTBR. Generally we don't expect this question for electrical students, but unfortunately it is given, okay. This is also, but this is also a formula based question, okay. The RMS noise voltage from an amplifier is given by this formula. So everything is given, the K is Boltzmann's constant, this is 1.38 into 10
10 power minus 23 joules per Kelvin. This is, and T temperature in degree Kelvin, temperature is given 25 degree centigrade. Okay, so plus 273 will be converted to degree Kelvin. So this is 298 Kelvin. Okay, the bandwidth is given 4 megahertz. This is 4 into 10 power 6 hertz, and the resistance is given as 10 kilo ohm. So 10 into 10 power 3, this is 10 power 4. So by substitution, okay, just substitute all these values here. So definitely the cal C is required for this. Okay, but fine. Okay, this is it is the problem with ESE. Okay, so to compute this, the calculator is required, but okay, but you have to do this, no other option. So if you simplify it, it comes to be 25.65 microvolts. So option C is going to be correct for this. Okay, so these are the questions from communication systems. Okay, so the next subject will continue. Okay, will be continued. Thank you. In this example, what is our requirement is the average value. Is asking the average value for which time? Average value correspond to 1 to 7 seconds. 1 to 7 seconds. To find out this average value, the simple approach for this one is simply we can write this with the area by respect to time. Area by respect to time. In the given example is asking this average value for the 1 to 7 seconds. 1 to 7 seconds. First, if you observe the 1 to 3, 1 to 3, what is the amplitude given as a 1.5? 1.5 is a constant value. Here the 1 to 3 means for this interval, what the time of this one is a 2. What the time of this one is a 2 seconds. Next one is the 3 to 5. 2 seconds. Now for this interval, what is the magnitude given as a -2. Next one is 6 to 7. 6 to 7 seconds. What the time is a 1 second. What about the amplitude given as a 1? What the total time for this one is a 6, because in the question is asked the 1 to 7 seconds. If you simplify this one, what is the average current? Average current is equal to 0. Average current is equal to 0. Now for this example, what is the requirement is this is a I5 current and I3 current. देखो जी, here to conclude the answer easy way. To conclude the answer easy way, can you apply the KCL at this point? For this example, can you apply KCL at this point? If you apply the KCL at this point, now for this example, 10 is the incoming, what the 5 is the outgoing. Always incoming current equal to outgoing current.
Now what is the current of this one is 5 amperes. In the question itself given what the current of this branch is 3 amperes. Now 5 is the incoming, 3 is outgoing, what remaining current of this one is 2. Now what is I5 equal 2 amperes. I5 equal 2 amperes. If you observe the options, now you can check it out. B is incorrect, C is incorrect, D is incorrect. Which one is supporting here? A. Honorable, you can verify that other answer also. Now for this other answer, they go 5 is the incoming current, 5 is the incoming current. But the 4 is the outgoing current. Remaining current of this one is what the current of this one is 1 ampere. No, current of this one is 1 ampere. Simply we are using application of the KCL. Now for this example here, what is our requirement is asking what is the current delivered, what is the current delivered by 10 volt source. To get the answer for this one, you can go for either nodal analysis or the mesh analysis. The choice is yours. Now here I am going for nodal analysis. Suppose if I name this one node A, node voltage is VA, node voltage VB, and other one is a VC. Now with respect to ground potential, what is the polarity for this one is a plus. With respect to ground potential, what is the polarity for this one is a plus. Now let us write the KCL equation correspond to each node. Now by KCL, come to node 1. Now correspond to this node 1, if you write the KCL equation, we can write plus plus subtraction. What the corresponding resistance of this one is 5. Now similarly here plus plus subtraction. The corresponding resistance is 8. Now correspond this one plus minus means addition. Now here the plus plus subtraction. The corresponding resistance of this one is 4. This entire equation is equal to 0. Now we got the equation 1. Similarly, you can develop the equation for the node 2 also. Similarly, come to the node 2. Now correspond node 2, we can write this as a VB by 20. Whenever you are writing equation at the node, assumption respect to node voltage greater. Now plus plus subtraction. This entire equation is equal to 0. Now come to node 3. Now correspond node 3, again we can write this VC by 25. Now this correspond this one here plus plus subtraction. The current of this branch depends upon the VC and VA, and other one is 20. But the resistance of this one is 4. This entire equation is equal to 0. Now in the given example, what is asking the current delivered by the 10 volt source. By solving these equations, can you find out respect to node voltages? According to our requirement, first try to find out the VA value. Solve the equations, find out VA value. After finding VA value, what is the requirement is the current delivered by current source. Current delivered by this 10 volt source. If I name this as I, 10 minus VA by respect to resistance is 5. First find out the VA value, simplify karo. Simplify karne se we can get this current. Check it out. C is the correct option for this one. In this example, what is the requirement is asking the respect to Thevenin's equivalent resistance. Is asking the respect to Thevenin's equivalent resistance. To find out Thevenin's equivalent circuit, Thevenin's equivalent resistance, we can go for so many methods. Now one of the approach for this one, I am deactivating all the independent sources. Deactivating all the independent sources. This voltage source is replaced by short circuit. Voltage source replaced by short circuit. Now then after here across the AB terminals, assume the any source. You can go for any source, the choice is yours. मान लो I selected IS equal to 1 ampere. Now I deactivate this one here. Now by doing the calculations, we have to find out the voltage across A and the B, voltage across A and B. For that one, simply can write the node equation here. Now node voltage for this one is VAB. With respect to ground potential, what is the polarity for this one is a plus. Dekho ji, here I is the incoming current. What about 9I also incoming current? What about the 1 ampere is also incoming current? What about the I1 is the outgoing current? I1 how to write is VAB by 200. Incoming currents equal to outgoing currents. In this example, what is our requirement is a VAB? What is our requirement is a VAB? For that one, let us focus on I. In this example, आप इधर देखें तो I current correction कैसे जा रहा है? Current going from lower potential to higher potential. Then what is the sign for this one? Minus. Minus VAB by resistance कितना is 2000. Can you substitute this equation 2? Can you substitute this equation 2 in equation 1? Now substitute the equation 2 in equation 1. Substitute equation 2 in equation 1. Now simplify करने से we can find out VAB value. Check it out. Here the VAB equal to 100 volts. VAB equal to 100 volts. Now finally, what is our requirement is the R Thevenins. Finally, what is our requirement is the R Thevenins. R Thevenins with respect to AB terminals. Now with respect to AB terminals, what is the voltage of VAB and corresponding source current is the IS. Now in this example, what is VAB is 100. Now what do we assume the IS equal to 1 ampere. Then what is resistance equal to 100 ohms.
This question is belongs to the transient analysis. Here this is a now experimental approach. One is okay. Now this is given an experimental circuit as shown in the figure below, has the variable resistor RL which is adjusted to the value of the load resistance 10 ohms. Here load resistance is 10 ohms only. It's not a, don't take a 30 ohms. Actually maximum power means RL is equal to RS, but is a load resistance value is fixed. Whenever if you take a maximum power, if you draw the P versus suppose power versus R, it will be rising. At this RL is equal to RS actually. But here RL value is less than RS value here. So directly you can write, first find out I is equal to V by RS plus RL. Don't take a 30 ohms here now. So V is 10 by 30 plus 10 is a 1 by 4. P is equal to 1 by 4 I square into R, that is R value is 10, will get a 625 milliwatts. The answer is here is a D option is the correct answer for this question. So don't take a 30 ohms here now. Most of the members are do the mistake. Even though you take a 30 ohms, here there is a no matching of your options. Okay. Next question. Move to the next question. So this is belongs to the transient analysis. Asking the question is, here is the first is charge to a capacitor C here. Say E value is given is 100 volts. E is equal to 100 volts. Now once you are charged and it is moved to the 3, this means a source free circuit, now it will be discharged to the resistance, this is discharging now. So at 5 volts, this 100 volts to 5 volts. 5 volts आने के लिए how much time will take? Directly option से कर सकते हैं. So don't take now your race. Don't do the calculation here now. Don't do the calculation. If you take a calculation, source free circuit, what is the now formula is V is equal to, suppose volt across capacitor Vc is equal to initial voltage e power minus t by tau. Here V is 5 volts आने के लिए how much time will take? Here initial voltage is 100 e power minus t by tau. You have to calculate, you get a time constant. You get a what the time is, but don't do the total problem here now. Why? Because your calculator is not available in your examination. इसलिए directly देख के बोल सकते हैं. So what is the time constant for this one? Tau is equal to RC. R is equal to how much here now? R is equal to is given at 10 kilo ohms, 10 into 10 cube into 0.05, 0.005 into micro 10 to the power of minus 6. So total is how much here now? Here nearly 50 microseconds. This value is 50 microseconds. One time constant के लिए how much here 36% reduce होता है. So here 5 वोल्ट्स के लिए हाउ मच परसेंट रिड्यूस होना चाहिए, 95% रिड्यूस होना चाहिए. 95% मीन्स 3 टाइम कांस्टेंट, 1 टाइम कांस्टेंट 36%, 2 टाइम कांस्टेंट 36% राइज होता है, 63% राइज होता है, 36% यार लूज होता है. सो हियर इज 95% रिड्यूस करने के लिए 95% मीन्स 100 minus 95 5 volts. So 3 time constant whenever it reaches, then the value is equal to 5 volts. Directly 3 time constant, 3 into 50 microseconds, this is 150 microseconds directly. There's no need to do, even though do you get an answer, but here logarithm में आते हैं इधर, you getting a log, so you are unable to solve and without calculator. He said the answer is D is the option is correct. D option is correct. Okay. Now move to the next question. Here is a circuit composed with a series combination of sinusoidal voltage source Vs is given and 500 ohm resistance. Here 500 ohm resistance and 30 millihenry inductor, unknown impedance, and the voltage source. There is a maximum average for maximum power के लिए Z L is equal to Zs conjugate or not directly. So what is Zs is equal? Zs is equal to R plus J XL or not. Here R is equal to how much? 500. JXL is equal to J omega L. Omega is equal to how much? 100 into L is equal to how much? 30 millihenry. 30 into 10 to the power of minus 3. This value is 500 plus J3. Conjugate means, so ZTH or ZL is equal to, for maximum power, 500 minus J3 ohms. This is the option. So 500 minus J3 ohms is a C is the option is correct for this question. Okay.
I will be dealing some questions in transformers. Question number 88. The ideal two winding transformer, primary and secondary windings have N1 100 turns, and what is asked is the primary terminal voltage. You can take induced EMF. E is equal to N d5 by dt volts. Here in the option there are two. One is plus, other one is minus. So if you keep plus sign, you will get option A. If you keep minus sign, you will get option B, like that. There's an issue. So general confusion is what you have to consider. There are two notations. One is field theory notation, other one is network theory notation. As an updated one, you have to go with plus sign only, because negative sign don't have any physical significance in providing that value. So go with network theory convention, that plus n d phi by dt. So if you apply plus n d phi by dt, 100 into d by dt of this. If you apply, you will get B as the answer. Next question, a 345 kV transmission line feeds a distribution substation that in turn has radial feeder to 4160-2400 volts. When you see this and when you see this, generally you might take this is the transformer, but it's not. The question context is not that actually. There is a transformer which is stepping down 345 kV to 4160 or 2400. This is a 3-phase 4-wire system. This is line to line voltage. This is line to neutral actually. So here, according to the context of question you have to take, there is a delta Y transformer where the primary has a voltage 345 kV, secondary across line to line 4160, across line to neutral 2400. If you put 4160 by root 3, you will get 2400. That's the context actually. So now this is a 100 MVA transformer. So now it's simple. If you want to calculate the current, root 3 VL IL is equal to 100 MVA. You know VL 345 kV. If you substitute 345 kV here, you will get IL value, that is 167.35. This is the answer. Next, question number 91. The magnetic core of large transformers are built in stepped cores. As you see in theory, instead of a normal core, if you make it into a stepped core, the mean diameter of turns will reduce. So when the turn diameter reduces, automatically the copper requirement and the copper losses will reduce. That's the answer. Minimize the use of copper and decrease copper loss. Next, 92. An auto transformer has an advantage over equivalent two-winding transformer. There are many advantages, but if you see the options, no electrical isolation is not an advantage. Greater short circuit current is not an advantage. Higher excitation current is not an advantage. Lower leakage reactance, because this is a one-winding transformer, as some part of the winding is common for both input as well as output. As it is one winding, basically the leakage reactance will be as low as possible. So obviously leakage reactance will be minimum, lowest. So definitely this is the advantage over a two-winding transformer. Question number 96. This is a stepper motor question. What is asked in this question basically is this. At the end you will see, then the rotor angular motion per pulse is a step off. The target is you have to find out the step angle in radians, that's it, nothing else. If you read this question, entire question 2 times, you will find to a conclusion finally this. You want to find step angle of the stepper motor in radians, nothing else. Data is given already. 2p, number of phases. K, number of teeth. You already know step angle formula alpha is equal to 360 degrees by m into nr. M, number of phases, nr is the number of rotor teeth. According to the question, m is given already 2p. nr, you can take k. This is degrees. And what you are asked is step of radians. This is that. If you see the solution, the rotor angular motion in steps, you have to express the step of radians. So, into pi by 180. This is pi by pk radians. Answer is D. Next question number 150. Transformers take advantage of the high magnetic energy density of the ferromagnetic material to allow economical device design. However, the non-linear nature of ferromagnetic material, you know, according to BH curve characteristics, if you want to operate at a better density for economic reasons, to reduce the area, everything, so generally preferred is knee zone, which is a non-linear zone. Because of this non-linearity, there will be some harmonics produced in the voltage and currents, as you know. This is the right statement. That's the conclusion actually from the topic excitation phenomena, right? If this is the second statement, this is totally a different scenario. This is about inrush currents. The non-linear nature of the transformer magnetizing inductance can lead to transient inrush currents, significantly greater than the rated value, obviously. Second statement is true, first statement is also true, both are individually true, but the second one is not conveying or supporting or explaining anything about the first statement. So answer is B. Remaining questions, my colleagues will continue.
So, in this question 85, isolating transformer, it is asked about isolating transformer. Isolating transformer basically used to isolate two circuit, right. So in this isolation, even the voltage rating will be same, but still we use it so that it can block the basically direct signal and it can transfer AC signal, correct? So our answer will be blocking direct current signal while maintaining AC continuity between circuits. So in AC this will transfer AC from this circuit to this circuit, but DC will be not allowed, because in transformer DC will be not allowed. So what will be the answer? C will be our answer, right? Now come to the next. When there is no ferromagnetic material but only air present, so there is a some kind of out of the box question is there, right? अब इस क्वेश्चन के अंदर देखें तो अब आयरन कोर स्टील कोर तो होगा नहीं, और वेट टाइप और ड्राई टाइप, तो इसमें अगर चार में से जाना है तो ड्राई टाइप आप टिक कर सकते हैं, जनरली वो ड्राई टाइप होता है, करेक्ट? बाकी ये थोड़ा सा ऐसे था, एक कॉमन सेंस बेस्ड। अच्छा, नेक्स्ट आ जाइए, that is the objectionable audible humming sound in the core of the transformer, करेक्ट? तो ये हमिंग साउंड क्यों होता है? मैग्नेटो स्ट्रिक्शन के चलते होता है। तो ये जो हमिंग साउंड है बेसिकली दिस डिपेंड्स अपॉन फ्लक्स डेंसिटी आल्सो, इफ मोर फ्लक्स डेंसिटी इज देयर मोर साउंड विल बी देयर, करेक्ट? तो बट वी कैन नॉट डिक्रीज फ्लक्स डेंसिटी, बिकॉज इफ वी आर गोइंग टू डिक्रीज फ्लक्स डेंसिटी तो कॉस्ट एंड साइज विल अफेक्ट, राइट? तो बेसिकली दैट core staggering will be taken place over there, right? core staggering, but यहाँ पे stacking लिखा है, तो ठीक है, उसी सेंस में हम जा सकते हैं इस ऑप्शन के साथ, बट अच्छा ये होता कि core staggering होना चाहिए था यहाँ पे, बट ठीक है, that will be the fine. फ्लक्स डिक्रीज, फ्लक्स डेंसिटी डिक्रीज करके भी हो सकता है, लेकिन फ्लक्स डेंसिटी डिक्रीज इसलिए नहीं करेंगे क्योंकि फिर कॉस्ट और फिर साइज हमारा इम्पैक्ट हो जाएगा, राइट? तो सी विल बी आवर आंसर। नाउ कम टू द नेक्स्ट क्वेश्चन, that is the synchronization, right, of alternator with the bus bar. तो पॉइंट यहाँ पे ये है, ये क्या पूछ रहा है? the lamps will blink off and on, means ऑन ऑफ हो रहा है, करेक्ट? दैट इज द फ्लिकरिंग वी कैन से। तो फ्लिकरिंग फ्रीक्वेंसी जो होती है दैट विल बी द बीट फ्रीक्वेंसी, एफ इनकमिंग माइनस एफ रनिंग का मॉड ले लीजिए, राइट? क्यों? क्योंकि अगर आप देखेंगे वोल्टेज, सारे ऑप्शंस को वैसे भी प्लेस करोगे तो वोल्टेज मैग्नीट्यूड ऑफ द सिंक्रोनस जनरेटर एंड द इलेक्ट्रिक यूटिलिटी आर नॉट मैच्ड। तो इफ वोल्टेज इज नॉट मैचिंग तो सिंपल सी बात है वो कभी भी ऑफ तो नहीं होगा ना, ऐसे करके आप सोच सकते हैं। सिमिलरली आप जस्ट एक्चुअली माय आंसर इज दिस, द फ्रीक्वेंसी ऑफ द ऑन गोइंग incoming होना चाहिए synchronous generator and the electric utility are not equal, that is right, and the beat frequency will be fi minus fr, and because of that beat frequency flickering will be taking place, correct? अब आ जाता है फेज सीक्वेंस। तो फेज सीक्वेंस में क्या होता है? फिर फेज सीक्वेंस में अगर ये अपोजिट होंगे तो फिर एक ऑन होगा तो बाकी सब क्या होंगे? बाकी सब ऑफ हो जाएंगे, ऐसे। फिर दूसरा ऑन होगा तो बाकी ऐसे सीक्वेंस में होंगे, ऑलरेडी वी हैव सीन इन द क्लास आल्सो, राइट? तो इसीलिए ये भी नहीं होगा और ये तो नहीं होगा, राइट? तो बी विल बी आवर आंसर, ओके? सो फॉर रिमेनिंग क्वेश्चन रोशन।
So welcome students, I am going to discuss question number 90. This question is from DC machine. A 4-pole lap wound DC machine armature has 54 slots with single turn coils. How many armature conductors are required if there are 2 coil sides per slot? So दो तीन चीजें बस आपको ध्यान रखनी है। Single turn coil. So single turn coil means like this. We have 2 conductors. these two conductors make single turn coil. And how many armature conductors are required if there are two coil sides per slots? In one slot we have two coil sides. So this is one coil side, this is another coil side, isn't it? And in a slot there is two coil sides. That means you can say that in a slot there are two conductors. सो एक स्लॉट में कितने कंडक्टर हो गए? दो कंडक्टर हो गए. यहां पर क्या दिया हुआ है? टू कॉइल साइड्स एंड दिस इज सिंगल टर्न कॉइल, सो वन कॉइल साइड विल हैव वन कंडक्टर्स. सो टू कॉइल साइड्स मीन वन स्लॉट विल हैव टू कंडक्टर्स. सो वन स्लॉट will have two conductors, isn't it? How many slots are there? 54 slots. So how many conductors? So for 54 slots we will have 2 into 54, that means 108 conductors. So D is the correct answer for this question number 90. Now question number 94. This is little bit tricky question. A 4-pole 50 Hertz 3-phase asynchronous motor is operating at a shaft speed of 1750 rpm. What is the speed of the stator air gap mmf? अब यहाँ पे आप एक चीज तो ये समझें कि स्टेटर एयर गैप एमएमएफ की बात की जा रही है. सो स्टेटर एयर गैप एमएमएफ विल नथिंग बट सिंक्रोनस स्पीड, इजंट इट? सिंक्रोनस स्पीड विल बी 120 f by p. इन आरपीएम इसी को हम लोग रेडियन पर सेकंड में कन्वर्ट कर सकते हैं 2 पाई बाई 60 से मल्टीप्लाई करके. हम तो सो जाएंगे भाई. 120 f by p. Think about this. This is 4-pole 50 Hertz 3-phase asynchronous motor is operating at a shaft speed of 1750 rpm. So अगर आप 4-pole 50 Hertz के लिए सिंक्रोनस स्पीड निकालते हो, so you will have 1500 rpm और रेडियन पर सेकेंड में it will be 157.07 रेडियन पर सेकेंड. Correct? But important point is this is a synchronous motor. देखो कोई भी मशीन या तो जनरेटिंग मोड में काम करेगा या मोटरिंग मोड में काम करेगा. सिंक्रोनस मोटर दैट मींस इंडक्शन मोटर. जब हम इंडक्शन मोटर की बात करते हैं, सो रोटर स्पीड शुड बी लेस देन सिंक्रोनस स्पीड. दैट इज फाइन. इन जनरेटिंग मोड इट इज हायर देन सिंक्रोनस स्पीड. सो यहाँ पर क्या दिया हुआ है कि ये सिंक्रोनस मोटर दैट मींस इंडक्शन मोटर नॉट मशीन. अगर इंडक्शन मशीन लिखा हुआ होता तो ये मोटरिंग मोड में भी काम कर सकता था, जनरेटिंग मोड में भी काम कर सकता था. बट ये मशीन नहीं लिखा हो के यहाँ पे मोटर लिखा हुआ है. इसका मतलब ये अगर मोटरिंग मोड है तो मोटरिंग मोड में 1750 जो कि रोटर की स्पीड है, शाफ्ट स्पीड है, दैट शुड बी लेस देन सिंक्रोनस स्पीड. सो डेफिनेटली सिंक्रोनस स्पीड विल बी हायर देन 1750. सो 1750 से अबव अगर हम देखें तो एट फ्रीक्वेंसी 60 Hertz we will have synchronous speed 1800 rpm and corresponding to this 1800 rpm in radian per second we will have 188.49 radian per second. So according to me answer should be A not B because a 4-pole 50 Hertz ये designed है 4-pole 50 Hertz के लिए but it is exciting with 60 Hertz supply, then only it will run at 1750 when it operates in motoring mode. Fine. So according to me 94 का आंसर होना चाहिए A. Okay, thank you. So अब next subject के लिए आ रहे हैं. Thank you very much.
So hello everyone. So let us solve this question. This question is from EMT. It is a very simple type of question, but the the outlook is a little. It looks like कि पता नहीं क्या है. See, I will just give you a hint. The detailed solution you can see on the website. So this is how the capacitor is given, right? Fine. So this is given as 0. This point is 1, 2. Correct. And let us assume that this is your C10 cap. Let us say it is some notation you just give 6 nanofarad, and this is your C12, right? This is how much? So this is equal to 2 nanofarad, and let us say this is C20 cap, and let us say this is your 3 nanofarad. What you have to do is, I can write KVL here. So Q1, it can be written as C10 cap V1 voltage plus C12 cap V1 minus V2. Can I write like that? I will just show you a little later on. In the website you can see the detailed solution. Okay, fine. So this is V1. I can write it like this. So this is nothing but your Q1 is equal to C10 V1 plus C12 cap V1 minus C12 cap V2. Isn't it? So Q1 is equal to C10 cap plus C12 cap V1 minus of C12 V2, isn't it? So what I can do is, I can write it like this. Q1 is equal to C11 V1 plus C12 V2. Right, so they are asking the matrix, isn't it? So what they are asking? They are asking the matrix. So therefore I can say that what is C11? So C11 is equal to C10 cap plus C12 cap. So C10, C10, so 6 plus 2. How much it is? 8 nanofarad. And similarly, how much is C12? C12 is equal to minus of C12 cap. So how much is minus C12? It is 2 nanofarad. So minus 2 nanofarad. So this is sufficient to mark the answer. So what is the answer here you are getting? So 8, C11 is 8 and C12 is minus 2. Right, you can see that 8 and minus 2. What is the answer? It is D. Similarly for others. So for detailed solution you can see the website. So thank you everyone.
नमस्कार. तो इलेक्ट्रिकल के मेरे दोस्तों, आपके बाकी के सारे सब्जेक्ट डिस्कस हो चुके हैं. मेरा आखिरी सब्जेक्ट मटेरियल साइंस में आपके साथ डिस्कस करने जा रहा हूं, और क्योंकि मुझे बाकी और भी सब्जेक्ट ईडीसी, मटेरियल साइंस, ईसी का और जीएस का तमाम सारी चीज़ें करना था, तो आपके साथ मैंने सोचा सबसे अंत में आएंगे. अगेन 13 क्वेश्चंस पूछे गए हैं. सो मटेरियल साइंस ने अपना रिकॉर्ड मेंटेन रखा है. 13 क्वेश्चंस फ्रॉम दिस सब्जेक्ट अगेन. ठीक, दिस ईयर आल्सो. कुछ इजी क्वेश्चंस हैं, कुछ जैसा हमेशा मटेरियल साइंस में रहते हैं कि थोड़ा रटने वाले या अनप्रेडिक्टेबल टाइप, वैसे भी क्वेश्चन आए हैं. तो चलिए वन बाय वन देखते चलते हैं. अ स्मॉल रीजन ऑफ एन इम्प्योर सिलिकॉन क्रिस्टल विद डायमेंशंस दिस दिस दिस. सो वॉल्यूम दिया हुआ है, आप देखें अगर, तो दिस इज गिवन वॉल्यूम हैज ओनली द आयंस. एक स्मॉल रीजन है सेमीकंडक्टर में जिसमें सिर्फ आयंस हैं. ठीक है. प्रेजेंट विद द वॉल्यूम डेंसिटी ऑफ दिस. सो ये आयंस की डेंसिटी दी हुई है. द रेस्ट ऑफ द क्रिस्टल कंटेन्स इक्वल डेंसिटीज ऑफ इलेक्ट्रॉन्स एंड द पॉजिटिव आयंस. द नेट टोटल चार्ज ऑफ द क्रिस्टल. वैसे तो हम जानते हैं कि नेट क्रिस्टल हमारा इलेक्ट्रिकली न्यूट्रल रहता है, लेकिन क्वेश्चन में कह रहा है कि एक छोटा सा वॉल्यूम है. लेट अस सपोज ये वॉल्यूम. ठीक, इस वॉल्यूम में सिर्फ पॉजिटिव आयंस हैं, बाकी का पोर्शन जो है वहां पॉजिटिव आयंस के करस्पॉन्डिंग इलेक्ट्रॉन्स हैं. सो रिमेनिंग पोर्शन इज न्यूट्रल but this portion is having only ions, so this is not neutral. So इसमें कितने चार्ज हैं ये आपको कैलकुलेट करना है. अगर आप इसे यूनिट से भी कैलकुलेट करें तो भी क्वेश्चन बन जाएगा. नंबर ऑफ आयंस पर यूनिट वॉल्यूम दिया है, वॉल्यूम से मल्टीप्लाई कर दो और चार्ज से मल्टीप्लाई कर दो. सो बेसिकली द चार्ज विल बी, इस केस में अगर हम चार्ज कैलकुलेट करें तो चार्ज इज इक्वल टू, पहले देखिए कितने आयंस हैं, 10 टू द पावर 15, दिस मच ऑफ आयंस. कितने वॉल्यूम में, इस वॉल्यूम में. ठीक, ये वॉल्यूम कितना है 1.25 इंटू 10 टू द पावर -6 इंटू 10 टू द पावर -3 इंटू 10 टू द पावर -3. इतने नंबर ऑफ आयंस होंगे और हर एक आयन पे चार्ज कितना होगा, पॉजिटिव चार्ज है इलेक्ट्रॉन के मैग्नीट्यूड के बराबर, सो दैट इज 1.6 इंटू 10⁻⁻19 कूलम. सो इस रीजन में जो कि अनन्यूट्रलाइज्ड रीजन है, उस अनन्यूट्रलाइज्ड रीजन में इतना चार्ज पाया जाएगा. इसको सिंप्लीफाई कर लीजिए, तो मैंने कैलकुलेशन कर रखा है, आपके साथ शेयर कर लेता हूं. सो 1.6 इंटू 10⁻⁻19 एंड 10 टू द पावर 25, ये मैंने 15 लिख दिया गलती से, ये 10 टू द पावर 25 है, 10 टू द पावर 25 number of ions, 10 to the power 25, and volume is 1.25 into 10⁻⁻6, 10⁻⁻3 so ये कितना हो जाएगा 10 to the power 12, right? और ये 25, ये 19, इसको सॉल्व करेंगे तो दिस विल कम आउट एज 2 इंटू 10⁻⁻6 कूलम. आइडिया समझिए, बाकी कैलकुलेशन, क्योंकि मैं भी सुबह से आप लोगों के साथ हूँ, काफ़ी थकान भी हो गई होगी, तो कैलकुलेशन वेरीफाई कर लीजिएगा. मेरे जो स्टूडेंट हैं वो वैसे भी जानते होंगे कि मैं क्लास में भी कैलकुलेशन नहीं करता, आपको ही करना होता है. सो आइडिया क्या है कि पर यूनिट वॉल्यूम चार्जेस कितने हैं, ये वॉल्यूम से मल्टीप्लाई कर दीजिए, हर एक पर चार्ज कितना है प्लस 1.6 इंटू 10⁻⁻19, उससे मल्टीप्लाई कर दीजिए, इतने कूलम चार्ज आ जाएगा. सो आंसर फॉर दिस क्वेश्चन विल बी गिवन बाय ऑप्शन डी. सो इसका आंसर हो जाएगा ऑप्शन डी, क्वेश्चन फर्स्ट. अच्छा क्वेश्चन था, आप में से ज्यादातर लोगों ने इसे कर लिया होगा. नेक्स्ट चलते हैं. नेक्स्ट क्वेश्चन में कह रहा है कि व्हिच वन ऑफ द फॉलोइंग क्वांटिटीज इज अ मटीरियल पैरामीटर. मटीरियल पैरामीटर का मतलब प्रॉपर्टी, ठीक है. तो मटेरियल साइंस की जब हम डिफिनीशन पढ़ाते हैं तो उस समय ही आपको मटेरियल प्रॉपर्टीज की बात करते हैं, इलेक्ट्रिकल कंडक्टिविटी, थर्मल प्रॉपर्टी, मैग्नेटिक प्रॉपर्टी, लॉट्स ऑफ थिंग्स वी टॉक अबाउट. तो आप अगर देखें तो इनमें सिर्फ एक ही ऑप्शन ये है जो कि मटेरियल प्रॉपर्टी है, बाकी ये इलांगेशन तो डायमेंशन में चेंज है, दैट्स नॉट अ मटेरियल पैरामीटर. इलेक्ट्रिकल इलांगेशन या थर्मल इलांगेशन या लैटिस पैरामीटर, दीज आर नॉट गोइंग टू बी. सो मटेरियल पैरामीटर का मतलब ऑन द बेसिस ऑफ व्हिच यू कैन कैरेक्टराइज द प्रॉपर्टी ऑफ मटेरियल. सो ऑन द बेसिस ऑफ द इलेक्ट्रिकल कंडक्टिविटी यू कैरेक्टराइज द मटेरियल, ईदर कंडक्टर, इंसुलेटर एटसेट्रा. सो डी इज द राइट चॉइस फॉर दिस क्वेश्चन. नेक्स्ट क्वेश्चन पर आते हैं. द प्रॉपर्टी ऑफ पीरियोडिसिटी इन crystal structure is repeated in 3 dimensions. The positive ions occupy the corners of a cube as well as the centers of the cube face, right? Then these crystals are, तो देखो आयनिक क्रिस्टल की बात कर रहा है, पॉजिटिव आयंस की बात कर रहा है, इसका मतलब पॉजिटिव और नेगेटिव आयंस दोनों होंगे, ठीक. तो आपके पहले दो ऑप्शन तो आंसर नहीं हो सकते, क्योंकि ये जब आइडेंटिकल टाइप ऑफ एटम्स होते पूरे क्रिस्टल में तब हम बीसीसी, एफसीसी या सिंपल क्यूबिक की बात करते हैं, बेसिकली मेटल्स में इनकी बात करते हैं. सो दीज टू कैन नॉट बी योर आंसर. अब बचा है हैलाइट सेंटर्ड क्यूबिक क्रिस्टल और रॉक सॉल्ट टाइप क्यूबिक क्रिस्टल स्ट्रक्चर. इन दोनों में से कोई एक ऑप्शन आपका हो सकता है, ठीक, या तो सी हो सकता है या डी हो सकता है. करेक्ट आंसर जो है वो डी है, ठीक है. एक्चुअली ये NaCl में जो क्रिस्टल स्ट्रक्चर पाया जाता है उसे रॉक सॉल्ट टाइप क्रिस्टल स्ट्रक्चर कहते हैं. रॉक सॉल्ट टाइप क्रिस्टल स्ट्रक्चर ये उसी की बात कर रहा है. उस क्रिस्टल स्ट्रक्चर को अगर हम देखेंगे, सोडियम का एफसीसी होता है पॉजिटिव आयंस का और क्लोरीन का एफसी, और उसके इंटरपेनिट्रेशन की वजह से बनता है. तो यहाँ पर उसने क्लोरीन आयंस की बात नहीं की, सिर्फ सोडियम आयंस की बात की है. सो पॉजिटिव आयंस ऑक्युपाई द कॉर्नर्स ऑफ द क्यूब एज वेल एज सेंटर्स ऑफ द क्यूबिक फेस. सो बेसिकली जो सोडियम एफसीसी बना रहा है सिर्फ उसकी बात कर रहा है. तो NaCl जो रॉक टाइप में क्रिस्टल स्ट्रक्चर है उस दैट इज बिकॉज ऑफ द इंटरपेनिट्रेशन ऑफ द पॉजिटिव आयंस एंड नेगेटिव आयंस। नेगेटिव आयंस की यहाँ बात ही नहीं किया है, सिर्फ पॉजिटिव आयंस के बेसिस पर कर रहा है। सो राइट आंसर फॉर दिस क्वेश्चन इज गिवन बाय ऑप्शन डी। सो इसके लिए करेक्ट होगा डी ऑप्शन। ठीक है, थोड़ा डिफिकल्ट था, हालांकि रॉक साइड का नाम तो मैं लिखाता हूं जब सेरेमिक पढ़ाता हूं, बट इतना डेप्थ में हम लोग बात नहीं करते। बोलता जरूर हूं कई बार मैं क्लास में कि इट इज बिकॉज ऑफ द इंटरपेनिट्रेशन ऑफ द 2FCC स्ट्रक्चर। तो अगर किसी की फेवरेट मेमोरी में होगा या अपने आप से किसी ने लिख लिया होगा तो कर लेंगे, अदरवाइज तो मुश्किल था ये क्वेश्चन। चलिए आगे बढ़ते हैं। द इलेक्ट्रिकल कंडक्टिविटी डिपेंड्स अपॉन the volume of concentrations of holes and their mobility, the volume concentration of the electrons of conduction and their mobility, concentration of both electrons and protons. Protons किसी भी तरह की conductivity में participate नहीं करते. This cannot be answer. Concentration of electrons only नहीं, conductivity के लिए mobility का भी होना जरूरी है. This question is a little bit ambiguous. इस क्वेश्चन में कहीं पर भी ये नहीं कह रहा है कि वो सेमीकंडक्टर की बात कर रहा। अगर सेमीकंडक्टर की बात करता तभी हम होल्स की बात कर सकते हैं। ठीक है, अब वैसे भी कंडक्शन, इलेक्ट्रॉन्स इन कंडक्शन यानी कंडक्शन बैंड में इलेक्ट्रॉन की बात कर रहा होगा। ठीक है, तो ऑटोमेटिकली ए और बी दोनों सेमीकंडक्टर की तरफ इंडिकेट कर रहे हैं। जब भी कुछ ना लिखा जाए तो हमेशा कंडक्टिविटी ड्यू टू इलेक्ट्रॉन्स को हम लोग प्रेफर करेंगे। वैसे भी अगर मैं मान लूं कि ये सेमीकंडक्टर के लिए डिजाइन किया गया है तो एन टाइप इज प्रेफर्ड ओवर द पी टाइप सेमीकंडक्टर। मोस्ट ऑफ द डिवाइसेस वी यूज्ड टू डिजाइन विद द हेल्प ऑफ एन टाइप सेमीकंडक्टर। सो आंसर होने को ए और बी दोनों हो सकते हैं। अगर पी टाइप सेमीकंडक्टर है तो होल का कंसंट्रेशन और उसकी मोबिलिटी पर डिपेंड करेगा। अगर एन टाइप सेमीकंडक्टर है तो इलेक्ट्रॉन का कंसंट्रेशन और उसकी मोबिलिटी पर डिपेंड करेगा। अगर मेटल है तो मेटल्स में तो होल होते ही नहीं है, सिर्फ इलेक्ट्रॉन्स होते हैं, तो भी बी ऑप्शन सही है। तो कंडक्टर हो सकता है या सेमीकंडक्टर हो सकता है, और इन दोनों को इसमें बेस्ट ऑप्शन जो होगा वो बी होगा। सो हम इसमें बी के साथ जाएंगे। हालांकि क्वेश्चन थोड़ा सा एम्बिगुअस है, क्लियर करना चाहिए था किस तरह के मटेरियल के लिए बात कर रहा है, बट फिर भी आप देखिएगा कि देयर इज अ हाई प्रोबेबिलिटी कि जो आंसर आएगा वो बी ही आएगा। आप इलेक्ट्रॉन के हिसाब से कंडक्टिविटी को जज करिए। सो कंसंट्रेशन ऑफ इलेक्ट्रॉन यानी वॉल्यूम कंसंट्रेशन ऑफ कंडक्शन इलेक्ट्रॉन मींस फ्री इलेक्ट्रॉन एंड देयर मोबिलिटी, वो डिसाइड करेंगे कि कंडक्टिविटी कितनी होगी। सो दिस इज क्वेश्चन नंबर 51। नेक्स्ट चलते हैं। द क्लासिकल थियरी ऑफ डायमैग्नेटिज्म ऑफ द बॉन्डेड इलेक्ट्रॉन्स इन अ फ्री एटम वाज एलेबोरेटेड बाय, ये मैंने नहीं पढ़ाया है। ठीक है, तो ये एक क्वेश्चन हो सकता है कि मेरे स्टूडेंट्स ना बना पाए हों, या कभी किसी ने बुक वगैरह पलटी होगी या कहीं किया होगा, या 12th के लेवल पर कुछ पढ़ा होगा तो याद आ सकता है। ये जो क्लासिकल थ्योरी एटम्स के लिए दिया था, वो क्लासिकल थ्योरी दिया था लॉन्गेविन ने। बेसिकली जो इनका पूरा नाम था वो पॉल लॉन्गेविन था। हिज फुल नेम वाज पॉल लॉन्गेविन। इन्होंने क्लासिकल थ्योरी दिया था एटम्स में डायमैग्नेटिज्म के बारे में। बेसिकली इन्होंने बताया था कि नेगेटिव मैग्नेटिज्म कैसे प्रेजेंट होता है जब हमारे पास इलेक्ट्रॉन ना हो, एक न्यूट्रल एटम हो, तो उसमें किस तरह से नेगेटिव मैग्नेटिज्म प्रेजेंट होता है, इस बात का डिस्कशन किया था। सो इसे हम कह सकते हैं कि जो राइट आंसर इसमें होगा वो ऑप्शन ए होगा। ठीक, सो एज फार एज माय स्टूडेंट्स आर कंसर्न्ड, उनके लिए ये मुश्किल हो सकता है क्योंकि मैंने कभी लॉन्गेविन का नाम नहीं लिया क्लास में, तो मुझे लगा कि शायद नाम साइंटिस्ट के उतने इंपॉर्टेंट नहीं है, लेकिन फिर भी क्वेश्चन बनाने की तो बन सकता है। सो वहां से बन गया। Which one of the following is the process of heating a material to just below its melting point? ठीक, अब ये क्वेश्चन ऑप्शन एलिमिनेशन से आप कर सकते हो, ना भी प्रोसेस पता हो तो भी। स्ट्राइप्स जो होते हैं कुछ नहीं, स्ट्राइप्स बेसिकली ये सुपर कंडक्टर्स के लिए एक फिनोमिना होती है जहां पर स्ट्राइप फेजेज होती हैं, लेकिन यहाँ क्या कह रहा प्रोसेस। सो ये फेज नहीं हो सकता, ये ऑप्शन नहीं है। स्ट्राइप्स वैसे भी आप स्ट्रिप से पढ़ करके कई लोग इसे काट सकते हैं, फर्जी ऑप्शन है। जोसेफ्सन जंक्शन होता है, आपसे क्या कह रहा है कि प्रोसेस की बात कर रहा है। स्क्विड एक डिवाइस होती है, मैंने आपको शायद सुपर कंडक्टर्स में पढ़ाया होगा, मेंस के बैच में तो पढ़ाया था, प्रीलिम्स का नहीं याद है कि इसकी बात की या नहीं की, स्क्विड के बारे में। तो ये भी जोसेफ्सन जंक्शन पर ही बनी हुई डिवाइस होती है। बेसिकली इसका जो आंसर होगा वो सिंटरिंग होगा। सिंटरिंग एक प्रोसेस होती है जहां पर हम लोग मटेरियल के कॉम्पैक्टिंग और फॉर्मिंग करते हैं सॉलिड मास को बाय अप्लाइंग pressure or just below the melting temperature. Actually अगर इसको properly define करें तो sintering is the process of compacting and forming a solid mass of material by pressure or heat without melting it to the point of liquefaction, यानी just melting point के below तक ये process perform की जाती है। तो इसका जो आंसर होगा वो A होगा। थोड़ा दिमाग लगाएंगे आप तो ऑप्शन एलिमिनेशन से इसे कर सकते हैं बिना सिंटरिंग की डिफिनीशन जाने हुए। मैं यहाँ डिफिनीशन लिख नहीं रहा हूँ, वो डिटेल सॉल्यूशन में आपको वेबसाइट पर मिल जाएगा, थ्योरी लिख करके कोई फायदा नहीं है। Next is which one of the following are the mixtures of materials used for the sliding contacts which appear between the trolley and the trolley cable in the electrical traction of high braking power? ये difficult question है। मैंने आपको पढ़ाते वक्त भी बताया था कि कुछ क्वेश्चन रटने वाले आते हैं और खास तौर पर एलॉयज के लिए, लेकिन यहाँ पर कुछ ऑप्शन एलिमिनेशन लगा सकते हो। गोल्ड बेस्ड एलॉयज हम लोग जल्दी से इलेक्ट्रिकल कंडक्टिविटी के पॉइंट ऑफ व्यू से नहीं यूज करते। ट्रैक्शन का अगर जिसको आइडिया होगा तो आपको ये आइडिया होगा कि ये जो मटेरियल है वो कंडक्टर होना चाहिए, तो हम गोल्ड एलॉयज को तो नहीं जल्दी से प्रेफर करते हैं। गोल्ड सेमीकंडक्टर में थोड़ा बहुत ऐड किया जाता है और ट्रैक्शन बहुत पॉपुलर फिनोमिना, वैसे भी इतना महंगा मटेरियल नहीं यूज होगा, तो गोल्ड वाले दो ऑप्शन काट दीजिए। अब इन दोनों में से कोई हो सकता है, अगर किसी को जानकारी होगी तो कॉपर और एल्युमिनियम की एलॉयज को हम लोग कंडक्टर या जहां पर अच्छी स्ट्रेंथ के कंडक्टर्स की जरूरत होती है वहां पर यूज करते हैं। तो कॉपर और एल्युमिनियम दोनों ढूंढिए। सो इलेक्ट्रोलाइटिक, बाकी तो देखो सिल्वर वगैरह कॉमन है सभी में, तो कॉपर यहाँ वो इलेक्ट्रोलाइटिक कॉपर या कॉपर, उससे नहीं परेशान होना, कॉपर ठीक है। देन लेड, ब्रॉन्ज, अब ब्रॉन्ज भी एक एलॉय है, ठीक है, उसको छोड़ देते हैं। बेरिलियम, कैडमियम, इस ऑप्शन में कहीं भी एल्युमिनियम नहीं है, जबकि इसमें देखो सिल्वर, कॉपर, लेड, जिंक एंड एल्युमिनियम। सो हमने क्या कहा कि कॉपर और एल्युमिनियम की एलॉयज को इस तरह के एप्लीकेशन में खूब यूज किया जाता है, जहां पर आपको बेसिकली ये कंडक्टिंग मटेरियल है बट उसकी स्ट्रेंथ अच्छी चाहिए। सो प्योर मेटल ना यूज करके हम लोग एलॉय यूज करेंगे ताकि स्ट्रेंथ अच्छी हो। हालांकि एलॉय बनाने से कंडक्टिविटी कम हो जाएगी, रेजिस्टिविटी बढ़ जाएगी, बट एप्लीकेशन ऐसा है जहां पर हमें एलॉय की जरूरत है बिकॉज वी नीड स्ट्रेंथ एज वेल एज कंडक्टिविटी बोथ। सो फॉर दिस क्वेश्चन माय आंसर वुड बी ए। हालांकि इस तरह के क्वेश्चन मुश्किल होते हैं, सही दिमाग काम कर जाए सही टाइम पर तो बन जाते हैं, नहीं तो नहीं बनते हैं। ठीक, आइए नेक्स्ट क्वेश्चन की तरफ चलते हैं। Which one of the following is the element exhibiting anti-ferromagnetism at room temperature? Again ये very simple question है। आपको जब मैं फेरो के एग्जाम्पल्स लिखाता हूं तो फेरोमैग्नेटिक के 3 एग्जाम्पल बड़े पॉपुलर लिखाता हूं, फेरस, कोबाल्ट, निकिल। हालांकि मैं गैडोलिनियम एंड डायस्प्रोशियम भी लिखाता हूं। तो ये 3 तो क्या है, फेरो है, और हमसे पूछा क्या है, एंटी फेरो। तो ए आंसर नहीं हो सकता, बी आंसर नहीं हो सकता एंड डी आंसर नहीं हो सकता, बचा कौन सा, सी। सो आंसर फॉर दिस क्वेश्चन इज सी। बेसिकली क्रोमियम जो है वो रूम टेम्परेचर पर हमारा एंटी फेरो की प्रॉपर्टी शो करता है एंड स्लाइटली अबव टेम्परेचर पर जब हम जाते हैं, रूम टेम्परेचर से स्लाइटली अबव, तो ये पैरामैग्नेटिक कैरेक्टर शो करने लगता है। सो इसका जो सही आंसर है वो क्रोमियम है। लेकिन मैं यहाँ पर आपसे कहूंगा कि आपको अगर ना भी पता हो तो ऑप्शन एलिमिनेशन कर सकते हैं। You should be dead sure about this कि आयरन, कोबाल्ट एंड निकिल दे आर फेरोमैग्नेटिक। सो 3 ऑप्शन हट गए, तो जो बचा वो एंटी फेरोमैग्नेटिक। सो आंसर फॉर दिस क्वेश्चन इज क्रोमियम। नेक्स्ट वन, इलेक्ट्रो ऑप्टिक डिवाइसेस। इलेक्ट्रो ऑप्टिक डिवाइसेस मतलब ऐसी डिवाइसेस जो इलेक्ट्रॉनिक हैं बट ऑप्टिकल इंटरेक्शन कर रही हैं, यानी लाइट के साथ इंटरेक्शन कर रही हैं, दैट इमिट रेडिएशंस ऑफ डिफरेंट कलर्स। ठीक, अब भाई रेडिएशन इमिट कौन सी डिवाइस करता है, लाइट इमिटिंग डायोड, एलईडी। ठीक, फोटो रजिस्टर्स जो हैं ये इमिट नहीं करते। फोटो कंडक्टर्स या फोटो रजिस्टर्स आपने देखा होगा, तो इन पे लाइट पड़ती है, उसकी वजह से इनकी कंडक्टिविटी या रजिस्टिविटी चेंज होती है। यहाँ क्या कह रहा है, रेडिएशन इमिट होना। ऑप्टो कपलर जो है, कपलिंग्स जो है, ये कोई एक डिवाइस नहीं, इट इज द कॉम्बिनेशन। ट्रांसमीटर एंड पर हमारे पास लाइट सोर्स होगा एंड रिसीवर एंड पर हमारे पास लाइट डिटेक्टर होगा, तो दोनों का कॉम्बिनेशन है। हमसे कह रहा है कि वो डिवाइस जो रेडिएशन इमिट करती है। वाइट जनरेटर फर्जी ऑप्शन है, तो यहाँ जो इमिटिंग डिवाइस है वो सी है, एलईडी इसका आंसर होगा। ठीक है, हालांकि ये मटेरियल साइंस से नहीं रिलेटेड है, लेकिन फिर भी मैंने उसमें रख लिया सेमीकंडक्टर मटेरियल के पॉइंट ऑफ व्यू से। आइए, द फिनोमिना वेयर सुपर कंडक्टिविटी इन अ मटेरियल इज सप्रेस्ड बाय एक्सीडिंग द मैक्सिमम करंट द मटेरियल कैन कंडक्ट और द मैक्सिमम मैग्नेटिक फील्ड इट कैन विथस्टैंड। यहाँ भी ऑप्शन एलिमिनेशन यूज करिए। सिंटरिंग अभी थोड़ी देर पहले हम लोग देख रहे थे, सो वो प्रेशर लगा करके लिक्विफैक्शन की टेक्निक है, वो तो ऑप्शन हो नहीं सकता। क्वेंचिंग मैंने क्लास में बहुत बार डिस्कस किया होगा, रैपिड कूलिंग करते हैं इस फिनोमेना में, तो सुपर कंडक्टर में कूलिंग से कोई लेना देना है नहीं, ठीक है। स्ट्राइप्स, एक्चुअली सुपर स्ट्राइप्स तो एक टर्म आता है जो फेस से जुड़ा हुआ होता है, यहाँ जो आंसर होगा वो डी होगा। मैं इस क्वेश्चन को डी डिफिकल्ट मानूंगा क्योंकि किसी का दिमाग काम करे या ना करे, हालांकि ये क्वेश्चन थोड़ा लॉजिक लगा के कर सकते थे आप। हमने आपको बताया है कि कोई एक कंडक्टर होगा, उसमें करंट फ्लो होगा तो एक मैग्नेटिक फील्ड क्रिएट होगी, और अगर ये मैग्नेटिक फील्ड तो मैग्नेटिक फील्ड कहाँ क्रिएट होगी, इस कंडक्टर की प्रॉक्सिमिटी में। तो अगर ये मैग्नेटिक फील्ड हमारी ग्रेटर हो गई क्रिटिकल मैग्नेटिक फील्ड, तो सुपर कंडक्टिविटी को डिस्टर्ब कर देगी, वही बात यहाँ पर लिखी हुई है। सो ये थोड़ा सा देखना जरूरी था, इसमें एलिमिनेशन वगैरह लगा सकते थे, उस हिसाब से आंसर हो जाएगा। डी विल बी द राइट आंसर फॉर दिस क्वेश्चन। व्हिच वन ऑफ द फॉलोइंग करेस्पॉन्ड्स टू द वेरिएशन ऑफ रोटेशन फ्रीक्वेंसी। रोटेशन फ्रीक्वेंसी का मतलब एंगुलर फ्रीक्वेंसी, ठीक, रोटेशन का मतलब एंगुलर फ्रीक्वेंसी या एंगुलर वेलोसिटी, दैट इज ओमेगा, ठीक, बाय द एक्सटर्नल फील्ड, ठीक। मैं आपको लार्मर एंगुलर फ्रीक्वेंसी लिखाता हूं अगर याद हो तो, ठीक, लार्मर एंगुलर फ्रीक्वेंसी, टेक्निकल सिलेबस जब आपका पढ़ाता हूं मैग्नेटिक प्रॉपर्टीज की, तो वहां बात करते हैं ओमेगा एल, ठीक। ओमेगा एल मैं आपको लिखाता हूं क्यू बी बाई 2m, जो कि बी अप्लाइड मैग्नेटिक फील्ड है, क्यू मैग्नीट्यूड ऑफ इलेक्ट्रॉनिक चार्ज है, एंड एम इज मास ऑफ इलेक्ट्रॉन। इसको हम लोग डिफाइन ही ऐसे करते हैं कि इट इज डिफाइंड एज चेंज इन एंगुलर फ्रीक्वेंसी ऑफ द इलेक्ट्रॉन ड्यू टू अप्लाइड मैग्नेटिक फील्ड। सो लार्मर फ्रीक्वेंसी इज डिफाइंड एज लार्मर फ्रीक्वेंसी basically that is the angular velocity. Larmor frequency is defined as the change in angular frequency, as the change in angular frequency as the change in angular frequency of the electron due to applied flux density, of electron due to applied field या flux density, जो भी लिखा हो, applied flux density that is B या applied field, both are interrelated, ठीक। This is the definition of Larmor frequency. So ये आप याद हो, जब मैं बोहर मैग्नेट्रॉन कैलकुलेट कराता हूँ तो उसके जस्ट बाद नोट में एक छोटा सा लार्मर फ्रीक्वेंसी पर पॉइंट देता हूँ। सो ऑप्शन डी विल बी द राइट क्वेश्चन चॉइस फॉर दिस क्वेश्चन। सिंपल क्वेश्चन था, करना चाहिए आपको अगर क्लिक किया होगा तो, ठीक है। चलिए नेक्स्ट क्वेश्चन की तरफ चलते हैं। सो दिस वाज अबाउट क्वेश्चन 58। लेट अस मूव ऑन टू नेक्स्ट क्वेश्चन। नेक्स्ट क्वेश्चन इज व्हिच वन ऑफ द फॉलोइंग एजेंट्स इन एन इंट्रिंसिक एजेंट, इंट्रिंसिक एजेंट वर्ड पर फोकस करना आपको, इनमें से कौन सा इंट्रिंसिक एजेंट है, ठीक, दैट इन्फ्लुएंसेस द कंडक्टिविटी ऑफ इलेक्ट्रो इंसुलेटिंग मटेरियल्स। अगेन ऑप्शन एलिमिनेशन यूज करिए। इंट्रिंसिक, ह्यूमिडिटी इन्वायरमेंटल फैक्टर है, एक्सट्रिंसिक फैक्टर है, टेम्परेचर इन्वायरमेंटल फैक्टर, एक्सट्रिंसिक फैक्टर है, प्रेशर एक्सट्रिंसिक है, ठीक है। तो इंट्रिंसिक क्या होगा, द नेचर ऑफ डाइलेक्ट्रिक। जब मैं आपको डाइलेक्ट्रिक ब्रेकडाउन पढ़ाता हूं तो मैं सबसे पहले यही लिखाता हूं इंट्रिंसिक ब्रेकडाउन, और वहां मैंने ये लिखाया हुआ एक लाइन आप नोट्स में देखिएगा कि नंबर ऑफ वॉइड्स एटसेट्रा डिफाइन द इंट्रिंसिक ब्रेकडाउन। सो नंबर ऑफ वॉइड्स किस मटेरियल में कितने होंगे, ये उसकी अपनी इंटरनल प्रॉपर्टी, इंट्रिंसिक प्रॉपर्टी, एंड दैट अफेक्ट्स द इंट्रिंसिक ब्रेकडाउन। इनफैक्ट ये लास्ट हेडिंग होती है डाइलेक्ट्रिक चैप्टर की, जब ब्रेकडाउन पढ़ रहे होते हैं तो 4 ब्रेकडाउन मैकेनिज्म्स लिखाता हूं जिनमें पहला इंट्रिंसिक ब्रेकडाउन है। सो इसका आंसर बी है। ना उतना याद हो तो भी आप कॉमन सेंस लगा करके भी इस क्वेश्चन को कर सकते थे। ह्यूमिडिटी, टेम्परेचर, प्रेशर ये सब इन्वायरमेंटल फैक्टर हैं, एक्सटर्नल फैक्टर हैं। सो इंट्रिंसिक जो है वो मटेरियल प्रॉपर्टी ही रह जाएगी। नेक्स्ट क्वेश्चन, इनफैक्ट लास्ट क्वेश्चन है, अ सेमीकंडक्टर इंडियम फॉस्फाइड मटेरियल बिहेव्स एज, कोई भी सेमीकंडक्टर हो, बिहेव्स एज एन इंसुलेटर। मैंने आपको क्या लिखाया है कि एट 0 केल्विन semiconductor behaves as a perfect insulator. Semiconductor behaves as a perfect insulator. Behaves as a perfect. So इंडियम फॉस्फाइड भी एक सेमीकंडक्टर है और 0 केल्विन पर ये एक परफेक्ट इंसुलेटर की तरह बिहेव करेगा, ठीक है, ये आपको पता है। अब 0 केल्विन तो किसी ऑप्शन में है नहीं, सो जरा देखो ऑप्शन देखते हैं, हाई टेम्परेचर, नहीं भाई हाई टेम्परेचर पर बहुत अच्छे कंडक्टर की तरह बिहेव करेगा, ठीक है। मीडियम टेम्परेचर, नहीं मीडियम टेम्परेचर पर भी सेमीकंडक्टर अपनी सेमीकंडक्टिंग प्रॉपर्टी को शो करता है। नॉर्मल रूम टेम्परेचर पर भी सेमीकंडक्टर रहता है, कंडक्टिविटी होती है। सो वेरी लो टेम्परेचर, 0 केल्विन इज नथिंग बट very low temperature. So at very low temperature semiconductor material will behave like an insulator. So answer for this question is given by option D. So these were the 13 questions जो इस सब्जेक्ट से पूछे गए थे और इसी के साथ आपका ये डिस्कशन भी कंप्लीट होता है। पेपर 1 काफी डिफिकल्ट था। पेपर 1 में मेरे हिसाब से अगर आप 40 प्लस स्कोर आपका बन रहा है, सो दैट्स वेरी गुड स्कोर। पेपर 2 जैसा आता है मोर और लेस वैसा ही था, कुछ पार्ट इजी कुछ पार्ट डिफिकल्ट, ऐसा मिक्स पेपर आता है। ऑन द प्रेडिक्टेड लाइन भी था, जैसे आप देखें ये 13 क्वेश्चंस हैं और इन 13 क्वेश्चन में से हमने जैसा हमेशा मटेरियल साइंस में कहते हैं कि 1-2 आपको रटने वाले आएंगे, बने तो बने नहीं तो नहीं बने, बाकी ज़्यादातर बन जाएंगे। तो कुछ वैसा ही यहाँ पर भी है, 2-3 क्वेश्चन डिफिकल्ट कह सकता हूँ, बाकी के क्वेश्चन आप बना सकते थे, 4 डिफिकल्ट मान लो तो भी बन सकता था। सो मेरे हिसाब से टेक्निकल मोर और लेस जैसे होता था वैसा ही है, थोड़ा बहुत कैलकुलेटिव हो सकता है कुछ जगहों पर, वो रहता है, ठीक। जीएस डिफिकल्ट था, तो ओवरऑल अगर दोनों को मिलाया जाए तो ये कह सकते हैं कि रिलेटिवली डिफिकल्ट साइड पर ही पेपर था। 1 और 2 को मिला लिया जाए तो बिकॉज ऑफ पेपर 1। तो अगर पेपर 1 में आपका नियर अबाउट 40 समथिंग स्कोर बन रहा और पेपर 2 ठीक हुआ है आपका, तो आपको डिसअपॉइंट होने की ज़रूरत नहीं है। आप बड़े कॉन्फिडेंस के साथ अपनी मेंस की तैयारी कर सकते हैं पिछले साल की कट ऑफ वगैरह को देख करके, और उसके हिसाब से आप अपना प्लान कर सकते हो। अगर गड़बड़ भी हो गया है तो ये आखिरी एग्जाम नहीं है। और मैं जैसा कहता रहता हूं कि मतलब ये आपकी जर्नी का एक असफलता क्या प्रूव करती है? असफलता सिर्फ ये सिद्ध करती है कि सफलता का प्रयत्न अभी पूरे मन से नहीं हुआ है। तो आप पूरे मन से दोबारा एफर्ट करिए, कुछ ना कुछ अच्छा जरूर आपको जीवन में मिलेगा। अगर आपको मुझसे मिलना है, कुछ डिस्कस करना है, तो आप मुझे मैसेज लिखिएगा टेलीग्राम पर और हम लोग डिस्कस कर लेंगे कि आप किस सेंटर पर मुझसे मिल सकते हैं। यू कैन डिस्कस अबाउट फ्यूचर कोर्स ऑफ एक्शंस। अननेसेसरी में डिसअपॉइंट वगैरह होने की जरूरत नहीं है। ऑन द बेसिस ऑफ पेपर 1 तो बिल्कुल भी डिसअपॉइंट होने की जरूरत नहीं है। पेपर 1 वाज वेरी कैलकुलेटिव इन नेचर। जो सब्जेक्ट स्कोरिंग होते हैं उन्हीं सब्जेक्ट में बहुत लेंदी क्वेश्चंस थे, सो बहुत कैलकुलेटिंग था, तो वो सबके लिए डिफिकल्ट था, वो अकेले आपके लिए डिफिकल्ट नहीं था। पेपर 2 आपने ठीक ही किया होगा, अच्छा ही किया होगा। सो इंजीनियरिंग सर्विसेज हो गया है, 1-2 दिन रिलैक्स करिए, उसके बाद अपने आप के बारे में सोचिए कि आपका कैसा क्या परफॉर्मेंस है, एंड देन अकॉर्डिंगली आप फ्यूचर कोर्स ऑफ एक्शन अपने लिए डिसाइड करिए। कोई भी जरूरत मेडी जी से या मुझसे या किसी भी तरह की हेल्प की जरूरत है, यू कैन कॉन्टैक्ट अस, वी विल बी मोर देन हैप्पी टू हेल्प यू। सो आज इसी के साथ मैं इस सेशन को वाइंड अप करता हूँ। थैंक यू वेरी मच फॉर वॉचिंग अस। आप अपने रिव्यूज़ या कोई भी क्वेरी है, कुछ भी हम लोगों तक भेज सकते हैं। वी विल बी मोर देन हैप्पी टू एंटरटेन यू। थैंक यू वेरी मच फॉर वॉचिंग अस।